Welcome to my 100 subscribers special video. I will solve these 100 integrals in this video. And as you guys already know, we have a little tradition here on the channel. I have already solved 100 integrals for my 10 subscriber special video, and I'm continuing with that today. So here are 100 new integrals which we are going to solve in today's video. They are presented in the order in which they are given in the book. So as you guys know, King Leonidas once famously shouted, "Spartans, what is your profession?" Well, integrals was the answer he least expected. So in that manner, let's solve these 100 integrals without any further delay. So problem number 1 on our list is an integral differential of t divided by t1 plus ln of t. Area in which this integral is defined is for t's which are positive numbers strictly larger than 0. What we can do now is use a substitution that s is equal to ln of t, and then we get that the differential of s is 1 over t differential of t. That is going to give us an integral of ds divided by 1 plus s. And of course we can use a new substitution at this point, that p is equal to 1 plus s, and that means that the differential of p is equal to a differential of s. So the integral then becomes differential of p divided by p, which is equal to ln of p under the absolute value plus some arbitrary constant c. When we return the substitution, this is ln of absolute value of 1 plus s plus c, and that is equal to ln of absolute value of 1 plus ln of t plus c. The second integral on our list is an integral of 2 minus ln of t divided by t times differential of t. For this integral, the area in which it is properly defined is for all t's which are strictly larger than 0. We can again introduce the substitution that u is equal to 2 minus ln of t, and then we get that the differential of u is equal to negative 1 over t differential of t. Our integral is then transformed into negative integral of u differential of u, and that is equal to minus u squared divided by 2 plus some arbitrary constant c. This is then equal to, when we return the substitution, negative 1 half of 2 minus ln of t squared plus c. The third problem on our list is an integral of differential of x over x ln of x ln of ln of x. So this integral is properly defined for x different than 0 and x strictly larger than 0 and ln of x strictly larger than 0. Of course, x times ln of x times ln of x has to be different than 0, as it is in the denominator. So x is different than 0 and x is strictly larger than 0. ln of x is different than 0, and that means that x has to be different than 1, and ln of x has to be different than 0. Well, that means that ln of x is different than 1, and that means that x has to be different than e. And ln of x has to be larger than 0, so that means that x has to be strictly larger than 1. So area in which this integral is well defined is an open interval from 1 to e, a union from e to positive infinity. We can solve this integral by introducing the substitution that u is equal to ln of x, and that means that the differential of u is equal to 1 divided by ln x times 1 over x dx. Of course, our integral which we have started from is then transformed into an integral of differential of u divided by u, and that is equal to ln of absolute value of u plus c. And that is just equal to ln of absolute value of ln of x plus c. The fourth integral on our list is an integral of cosine ax plus b differential of x. Area in which this integral is defined is for a, b, and x real numbers. So we can introduce the substitution that t is equal to ax plus b, and then differential of t is equal to a times differential of x. Our integral is then transformed into 1 over e integral of cosine of t differential of t, which is equal to 1 over a times sine t plus a constant c, which is then equal to 1 over a sine of ax plus b plus c. And of course that is for a, which is different than 0. So if a is equal to 0, we have an integral of cosine ax plus b differential of x to be equal to integral of cosine b dx, and that is just cosine b as a constant times an integral of dx, and that is equal to cosine b times x plus c. Integral number 5 on our list is an integral of sine of square root of x divided by a square root of x differential of x. This integral is defined for x's which are strictly larger than 0, and by introducing the substitution that t is equal to a square root of x, we get that the differential of t is equal to 1 over 2 square roots of x dx. Well, two differentials of t are then equal to differential of x over a square root of x, and that is going to transform our integral into two integrals of sine t differential of t, which is equal to 2 times negative cosine of t plus an arbitrary constant c. So this is negative 2 cosine t plus c, which is equal to negative 2 cosine of a square root of x plus c when we return the substitution. So integral number 6 on our list is an integral of ctg of x differential of x. A little note here, ctg function of x is defined as cosine of x divided by a sine of x, and of course that is a cot function of x. Depending on the literature you use, you can find one or the other notation for one and the same thing. So this is equal to cosine of x divided by sine of x differential of x. In order for this integral to be well defined, sine of x has to be different than 0, and that means that x has to be different from kp, where k is an integer. So we are talking about the area set R without the dots kp, where k is an integer. This integral can be solved by using a substitution that t is equal to sine of x, and then we get that the differential of t is equal to a cosine of x dx. So then it gets transforms into differential of t over t, which is equal to ln of absolute value of t plus c, which is equal to ln of absolute value sine of x plus c. Problem number 7 on our list is an integral of tg of x dx. Tg of x is defined as sine of x divided by cosine of x, and that is a tan of x. So for tan of x you can find one or the other notation depending on the literature which you use. So this is then equal to an integral of sine of x divided by cosine of x dx, and in order for this integral to be properly defined, cosine of x has to be different than 0, and that means that x is different than p half plus kp, where k is an integer. So this is then equal to, we can use the substitution that t is equal to cosine of x, and that means that the differential of t is equal to negative sine of x differential of x. So the integral is transformed into negative integral of dt over t, which is negative ln of absolute value of t plus c, and that is equal to negative ln of cosine of x under the absolute value and plus c. Problem number 8 on our list is an integral of t times sine of t squared minus 1 differential of t. This t belongs in an R, and that is our area in which this integral is properly defined. We can solve it by using a substitution that u is equal to t squared minus 1, and then differential of u is 2t dt. So this is then going to give us that 1/2 of the differential of u is equal to t dt, and then our integral gets transformed into 1/2 of the integral of sine u differential of u, which is 1/2 of negative cosine of u plus c. So this is equal to negative 1/2 of the cosine of t squared minus 1 plus c. So the problem number 9 on our list is an integral of x cosine of x squared plus 1 differential of x. Area in which this integral is defined is for all x's which are real numbers, and we can solve it by using the substitution that t is equal to x squared plus 1, and that is going to give us that the differential of t is equal to 2x differential of x. So x dx is 1/2 of the differential of t, and then our integral is transformed into 1/2 of the integral of cosine t dt, which is equal to 1/2 of the sine t plus c, and that is equal to 1/2 of sine x squared plus 1 and plus c. Integral number 10 on our list is an integral of cosine square root of x divided by a square root of x differential of x. Area in which this integral is defined is for x strictly larger than 0. We can use the substitution that square root of x is equal to t, and then 1 over 2 square x differential of x is going to be differential of t. Of course, differential of x over a square root of x is then equal to 2 differentials of t. So this integral is then transformed into 2 integrals of cosine t differential of t, and that is equal to 2 times sine of t plus c, which is 2 sine of square root of x plus c. Integral number 11 on our list is an integral of 3x divided by cosine squared of 2x squared differential of x. So cosine squared of 2x squared has to be different than 0, and that means that 2x squared has to be different than p half plus kp, where k is an integer. So that means that x squared is different than p divided by 4 plus kp over 2, where k is an integer, and that means that x has to be different than plus or minus a square root of p over 4 plus kp over 2, where k is an integer. We can solve this integral by introducing the substitution that 2 is equal to 2x squared, and then differential of t is equal to 4x differential of x, which means that 1/4 of differential of t is equal to x differential of x. So then our integral is transformed into the t world as 3/4 of the integral of differential of t divided by cosine squared of t, and that is 3/4 of tan of t plus c, which is 3/4 of tan of 2x squared plus c. Problem 12 on our list is an integral of differential of x divided by a square root of x cosine squared of the square root of x. Well, square root of x times cosine squared of the square root of x has to be different than 0, and x has to be strictly larger than 0. So cosine squared of the square root of x has to be different than 0, and that means that cosine of square root of x is different than 0. So square root of x is different than p half plus kp, where k is an integer, and that means that x has to be different from p half plus kp squared, where k is an integer. So area in which this integral is defined is for all x's which are from 0 to positive infinity, open interval, without the dots p half plus kp squared, where k is an integer. We can introduce the substitution that square root of x is equal to t, and that means that 1 over 2 square roots of x differential of x is differential of t. So differential of x over a square root of x is equal to 2 differentials of t. So our integral from the start is then transformed into 2 integrals of the differential of t divided by cosine squared of t, which is 2 times tan of t plus c, which is 2 tans of the square root of x plus c. Problem number 13 on our list is an integral from x squared differential of x divided by cosine squared of x cubed. So cosine squared of x cubed has to be different than 0, and that means that cosine of x cubed has to be different than 0. X cubed is then different from p half plus kp, where k is an integer. So that means that x has to be different from a cubic root of p half plus kp, where k is an integer. So this integral then can be transformed by using a substitution that t is equal to x cubed. So this is then differential of t times 3x squared equal to 3x squared differential of x, and that is going to give us that x squared differential of x is 1/3 of the differential of t. So this integral is then transformed into an 1/3 of the integral differential of t divided by cosine squared of t, and that is equal to 1/3 tan of t plus c, which is 1/3 of tan of the x cubed, and then plus an arbitrary constant c. Problem number 14 on our list is an integral of x differential of x divided by sine squared of 2x squared. So sine squared of 2x squared has to be different from 0. That means that sine of 2x squared is different than 0, and that means that 2x squared is different from kp, where k is an integer. So that means that x squared is different than kp half, where k is an integer, and that means that x has to be different from plus or minus kp over 2, where k is an integer. So area in which this integral is defined is for all real numbers except the numbers square root of kp half, where k is an integer, or the numbers negative square root of kp half, where k is an integer. We can introduce the substitution that 2x squared is equal to t, and then we get that 4x differential of x is equal to differential of t. That means that 1 over 4 differential of t is equal to x dx, and then our integral is transformed into 1/4 of the integral differential of t divided by sine squared of t, which is equal to 1/4 of negative cot of t plus c, which is negative 1/4 of cot. Of course, when we return the substitution, that is 2x squared, and plus an arbitrary constant c. Problem number 15 on our list is an integral of the differential of t over sine squared of p divided by 3 minus t. So this sine of p third minus t has to be different than 0, and that means that pi over 3 minus t is different from kp, where k is an integer. That means that t has to be different from p third plus kp, where k is an integer, minus kp, where k is an integer. So the area in which this integral is defined is for set of all real numbers except the numbers p third minus kp, where k is an integer. We can solve this integral by introducing the substitution that u is equal to p over 3 minus t, and that means that differential of u is equal to negative differential of t. Well, of course, this integral is then transformed into negative integral of du divided by sine squared of u. And this is then equal to negative minus cot of u plus c, which is just cot of u plus c. When we return into the t world, we get cot of p divided by 3 minus t plus c. So problem number 16 on our list is an integral of differential of x divided by x squared sine squared of 1 over x. X has to be different than 0 and sine of 1 over x has to be different than 0. That means that 1 over x is different than kp, where k is an integer, and that means that x has to be different 1 over kp, where k is an integer. So area in which this integral is defined is set of all real numbers, which we are going to exclude from dot 0 and all the dots 1 over kp, where k is an integer, except 0. We're going to introduce the substitution that 1 over x is equal to t, and then negative 1 over x squared differential of x is equal to differential of t. Well, that means that 1 over x squared differential of x is negative differential of t. Our integral then becomes negative integral of differential of t divided by sin squared of t, and that is equal to negative cot of t plus c, which is equal to cot of 1 over x plus c. Integral number 17 on our list is an integral of differential of x divided by x sine squared of ln of x. So sine of ln of x has to be different than 0 and x has to be larger than 0. That means that ln of x has to be different from kp, where k is an integer, and that means that x has to be different from e to the power kp, where k is an integer. So area in which this integral is defined is the set from 0 to positive infinity open interval, and we are going to exclude dots e to the power kp, where k is an integer, from that open interval. Let's introduce the substitution that ln of x is equal to t, and then 1 over x differential of x is equal to differential of t. Our integral is then transformed into the integral of differential of t divided by sine squared of t, and that is equal to negative cot of t plus c, which is negative cot of ln of x plus c. Problem number 18 on our list is an integral of sine squared of x cosine of x dx. Area in which this integral is defined is an entire set of real numbers. We are going to solve this integral by introducing the substitution that sine of x is equal to t, and that means that cosine of x dx is equal to dt. Then the integral gets transformed into t squared differential of t, which is t cubed over 3 plus c, and that is 1/3 of sin cubed of x plus c. Problem number 19 on our list is an integral of cosine cubed of x times sine of x dx. So cosine of x is equal to t is a substitution, and that means that negative sine of x dx is equal to differential of t. Of course, area in which this integral is defined is entire set of real numbers, and this integral is transformed into negative integral t cubed differential of t, which is equal to negative t to the 4th power divided by 4 plus c, and that is negative 1/4 of the cosine to the 4th power of x plus c. Problem number 20 on our list is an integral of cosine squared of x dx. Area in which this integral is defined is set of real numbers. We are going to use the following trigonometrical identities. Cosine squared of x plus sine squared of x is equal to 1, and cosine squared of x minus sine squared of x is equal to cosine of 2x. We can add these two identities to one another, and we get that 2 cosine squared of x is equal to 1 plus cosine of 2x, and that means that cosine squared of x is equal to 1 plus cosine of 2x divided by 2. Of course, this integral is then transformed into the integral of a 1 plus cosine of 2x divided by 2 differential of x, and that is equal to 1/2 integral of dx plus 1/2 of the integral cosine 2x dx. This is equal to 1/2 of x plus, and we can introduce the substitution that 2x is equal to t, which means that two differentials of x are differential of t. So this is plus 1/4 of the integral of cosine t differential of t, and then this is equal to x/2 plus 1/4 of sine t plus c, which is finally equal to x/2 plus 1/4 of sine of 2x plus c. Integral number 21 on our list is an integral of sine squared of x dx. Area in which this integral is defined is an entire set of real numbers, and we can rewrite this as 1 minus cosine squared of x dx. This is equal to an integral of dx minus an integral of cosine squared of x dx, and this is equal to x minus x half plus 1/4 of sine of 2x and then plus c. So this is x half minus 1/4 of sine 2x plus c. Problem number 22 on our list is an integral of cosine of 2x divided by sine of x cosine of x differential of x. Well, that means that in order for this integral to be properly defined, sine of x has to be different than 0 and cosine of x has to be different than 0. So that means that x is different from kp, where k is an integer, and x has to be different from p half plus LP, where L is an integer. So area in which this integral is well defined is the set of real numbers except the dots KP, where K is an integer, and except dots P half plus LP, where L is an integer. So this integral can be written as an integral of cosine 2x divided by 2 sine of x cosine of x dx. We added these two, so we have to also cancel it. So this is then equal to 2 integrals of cosine 2x, and this is just sine of the double angle differential of x. So sine of 2x is equal to t, and that means that 2 cosine of 2x differential of x is equal to differential of t. So this is equal to an integral of dt over t, which is just ln of absolute value of t plus an arbitrary constant c. So this is equal to ln of absolute value sine of the double angle x plus an arbitrary constant c. Problem number 23 on our list is an integral of sine x differential of x divided by 1 plus 3 cosine of x. So 1 plus 3 cosine of x has to be different than 0, and that means that 3 cosine of x is different than a negative 1. So cosine of x is different than negative 1/3, and that means that area in which this integral is defined is set of all real numbers except the dots a, where cosine of a is equal to negative 1/3. We can introduce the substitution that t is equal to 1 plus 3 cosine of x, and that means that the differential of t is equal to negative 3 sine of x differential of x. Sine of x differential of x is then equal to negative 1/3 of the differential of t. So this integral is then transformed into negative 1/3 of the integral dt over t, which is equal to negative 1/3 of the ln under the absolute value we have t plus an arbitrary constant c. So this is negative 1/3 of the ln of the absolute value 1 plus 3 cosine of x, and then plus c. Problem number 24 on our list is an integral of cosine x differential of x divided by 1 plus 2 sine of x. So 1 plus 2 sine of x has to be different than 0, and that means that 2 sine of x is different than negative 1. Sine of x is then different than negative 1/2. So area in which this integral is defined is set of all real numbers except the dots a, such that sine of a is equal to negative 1/2. So this integral can be solved by using the substitution that 1 plus 2 sine of x is equal to t. That means that 2 cosine of x dx is equal to a differential of t, and that means that cosine x dx is equal to 1/2 of the differential of t. This integral is then transformed into 1/2 of the integral of the differential of t divided by t, which is 1/2 of the ln under the absolute value we have t, and plus some arbitrary constant c. So this is 1/2 of the ln under the absolute value we have a 1 plus 2 sine of x, and then plus c. Problem number 25 on our list is an integral of 1 minus 2 cosine of x divided by sine squared of x differential of x. So sine of x has to be different than 0, and that means that x is different than kp, where k is an integer. So we are talking about the area of set of the real numbers except the dots kp, where k is an integer. We can solve this integral by introducing the substitution that sine x is equal to t, and that means that cosine x dx is equal to dt. So this is then equal to an integral of dx over sine squared of x minus 2 integrals of cosine x divided by sine squared of x dx, and that is then transformed into, well, this is a negative cot of x and minus 2 integrals differential of t over t squared. So this is negative cot of x minus 2 times 2 to the power negative 2 plus 1 divided by negative 1 and plus c. So this is negative cot of x and plus 2 times 1 divided by t plus c, which is just negative cot of x plus 2, 1 over sine of x and plus an arbitrary constant c. Problem number 26 on our list is an integral of dx over a sine of x. So sine of x has to be different than 0, and that means that x is different than kp, where k is an integer. So area in which this integral is well defined is set R without the dots kp, where k is an integer. This is then equal to an integral dx, and we can use the trigonometrical formula for the double angle. We get 2 sine of x half cosine of x half. This is then equal to 1/2 of the integral of dx divided by sine of x half divided by cosine of x half, and then we have to multiply by cosine to the power 2 of x half. So this can be then transformed into 1/2 integral of dx divided by tan of x half cosine squared of x half. We can then introduce the substitution that t is equal to tan of x half, and that means that 1/2 of 1 over cosine squared of x half, differential of x is going to be the differential of t. So this is then equal to an integral of differential of t divided by t, and that is equal to ln of the absolute value of t plus c, and that is ln of the absolute value 10 of x half and plus c. Problem number 27 on our list is an integral of dx divided by cosine x. So cosine of x has to be different than 0, and that means that x is different than p half plus kp, where k is an integer. Now we can use some trigonometry to get this integral solved. Namely, if we observe cosine of x plus p half, we get that this is equal to cosine of x times cosine of p half minus sine of x sine of p half. Cosine of p half is 0 and sine of p half is 1. So this is negative sine of x. Well, cosine of x can be written as cosine of x plus p half and then minus p half, and we get cosine of x plus p half cosine of negative p half minus sine of x plus p half sine of negative p half. So this is negative 1 and this is equal to 0. So we get sine of x plus p half. So this integral is then equal to an integral of dx divided by sine of x plus p half. What we can do now is to introduce the substitution that x plus p half is equal to t, and then we get that the differential of x is equal to a differential of t. This is then equal to an integral of dt over sine of t, and this is equal to ln under the absolute value we have 10 of t half and plus c. When we return the substitution, that is ln of 10 of x plus p half divided by 2 and plus c. So this is equal to ln under the absolute value we have 10 of x half plus p divided by 4 and then plus c. Problem number 28 on our list is an integral of cosine to the 5th power of x differential of x. So this can be written as an integral of cosine squared x and that to the 2nd power cosine of x dx. This is then equal to an integral of 1 minus sine squared of x squared cosine of x dx, and that can be using the substitution that t is equal to sine of x, differential of t is cosine x dx. This gets transformed into 1 minus t squared squared the differential of t. So this is an integral of 1 minus 2t squared plus t to the 4th power differential of t. So this is equal to integral of dt minus 2 integrals of t squared the differential of t and plus integral of t to the 4th power differential of t. So this is t minus 2 times t cubed divided by 3 plus t to the 5th power divided by 5. So this is sine of x minus 2/3 of the sine cubed of x plus 1 over 5 sine to the 5th power of x and plus an arbitrary constant c. Of course, area in which this integral is defined is set of real numbers. Problem 29 is an integral of sine to the power 7 of x dx. This is equal to an integral of sine to the 6th power of x times sine of x dx. And this is equal to an integral of sine squared of x cubed sine x dx, and that is equal to an integral of 1 minus cosine squared of x cubed sine of x differential of x. We are going to introduce the substitution that t is equal to cosine of x, and then we get that differential of t is negative sine of x differential of x. This integral is then transformed into negative 1 minus t to the second power to the third power differential of t. So this is minus an integral of 1 minus 3 times t squared plus 3 times t to the fourth power minus t to the sixth power differential of t. So this is then equal to integral of t to the sixth power minus 3t to the fourth power plus 3t to the second power minus 1 differential of t. This is equal to 1 over 7t to the seventh power minus 3 times t to the fifth power divided by 5 plus 3 times t cubed divided by 3 minus t and plus c. So this is equal to 1 over 7 cosine to the seventh power of x minus 3 over 5 cosine to the fifth power of x plus cosine cubed of x minus cosine of x and plus an arbitrary constant c. Area in which this integral is defined is set of all real numbers. Problem number 30 on our list is an integral of cosine x dx divided by sine to the fifth power of x. Well, sine of x has to be different than 0, and that means that x has to be different than kp, where k is an integer. Of course, we can solve this by introducing the substitution that sine of x is equal to t, and then cosine x dx is equal to a differential of t. This integral is then transformed into the integral of dt over t to the fifth power, and that is equal to integral of t to the power negative 5 differential of t. So this is equal to the t to the power negative 5 plus 1 divided by negative 4 plus c, which is negative 1/4 times 1 divided by t to the fourth power plus c. So this is negative 1 over 4 times 1 over sine to the fourth power of x and plus c. Problem number 31 on our list is an integral of sin x dx divided by cosine cubed of x. Cosine of x has to be different than 0, and that means that x has to be different than p half plus kp, where k is an integer. We can introduce the substitution that t is equal to cosine of x, and that means that the differential of t is equal to negative sine of x dx. Our integral is then transformed into negative integral of dt over t cubed, and that is equal to negative integral of t to the power negative 3 dt, which is equal to minus t to the power negative 3 plus 1 divided by minus 2 and plus c. This is equal to 1/2 of 1 divided by t squared plus c, and that is equal to 1 divided by 2 cosine squared of x plus c. Integral number 32 on our list is an integral of sine x dx divided by a square root of 1 plus 2 cosine of x. So 1 plus 2 cosine of x has to be larger than 0, which means that 2 cosine of x is larger than negative 1 half. So negative 1. So cosine of x has to be larger than negative 1 half. Area in which this integral is defined is for all x's such that cosine of x is larger than negative 1 half. Let us introduce the substitution that t is equal to 1 plus 2 cosine of x. That means that negative 2 sine of x dx is equal to a differential of t. Our integral then becomes negative 1 half of the integral dt divided by a square root of t. This is equal to negative 1 half integral to the power t to the power negative 1 half dt, and that is equal to negative 1 half times t to the power negative 1 half plus 1 divided by negative 1 half plus 1 and plus c. So this is then equal to a negative 1 half times t to the power 1 half divided by 1 half plus c, which is equal to negative square root of t plus c. That is minus a square root of 1 plus 2 cosine of x and plus c. Problem number 33 on our list is an integral of e to the power cosine x times sine x dx. So area in which this integral is defined is set of all real numbers. We can introduce the substitution that cosine of x is equal to t, and that means that negative sine of x dx is equal to dt. This integral is then transformed into negative integral of e to the power t dt, which is equal to negative e to the power t plus c, and that is equal to negative e to the power cosine of x and plus c. Integral number 34 on our list is an integral of 5 to the power sine x times cosine of x dx. So area in which this integral is defined is set of all real numbers. We can introduce the substitution that t is equal to sine of x, and that means that dt is cosine of x dx. This integral is then transformed into an integral of 5 to the power t dt, which is equal to 5 to the power t divided by ln of 5 plus c, which is equal to 5 to the power sine of x divided by ln 5 and plus an arbitrary constant c. Integral number 35 on our list is an integral of a square root of 1 plus 4 sine x times cosine of x dx. This integral is defined for 1 plus 4 times sine of x larger or equal to negative 1, which means that for sine x has to be larger or equal to negative, larger or equal than 0, larger or equal than negative 1. So sine of x is larger or equal to negative 1 over 4. Area in which this integral is defined is set of all x's such that sine of x is larger or equal to negative 1 over 4. We can introduce the substitution that t is equal a square root of 1 plus 4 sine x. Differential of t is then equal to 1 divided by 2 square roots of 1 plus 4 sine x times 4 cosine of x dx. This is then equal to 2 cosine x dx divided by a square root of 1 plus 4 sine of x. Well, this is then equal to 2 cosine of x dx divided by t, and that means that t dt is equal to 2 cosine of x dx. Well, that means that 1/2 of t differential of t is equal to cosine of x differential of x. When we return this into an integral, then it transforms into 1/2 of the integral t squared dt, which is equal to 1/2 times t to the power 3 divided by 3 plus c, and that is 1/6, a square root of 1 plus 4 sine of x, and that is going to be to the power 3. And of course plus an arbitrary constant c. Integral number 36 on our list is an integral of cosine to the 4th power x dx. So this can be written as cosine squared of x times cosine squared of x dx, and that is equal to an integral of 1 minus sine squared of x times cosine squared of x dx. Well, this is then equal to an integral of cosine squared x minus cosine squared x sine squared x dx, which is equal to an integral of cosine squared x dx minus an integral of sine squared x cosine squared x dx. So cosine squared of x plus sine squared of x is equal to 1, and we know that cosine squared of x minus sine squared of x is equal to cosine of 2x. When we add these two equations, we get that 2 cosine squared of x is 1 plus cosine of 2x, which means that cosine squared of x is equal to 1 plus cosine of 2x divided by 2. Then our integral becomes an integral of 1 plus cosine of 2x divided by 2 dx. And this integral can be transformed into negative 1/4, 2 times sine x cosine x, and then that entire term to the power 2 dx. Well, this is then equal to 1/2 integral dx plus 1/2 integral of cosine 2x dx minus 1/4 integral of sine squared of 2x dx. Now what we can do is we can write cosine squared of 2x plus sine squared of 2x is equal to 1, and cosine squared of 2x minus sine squared of 2x is equal to cosine of 4x. If we subtract these two equations from one another, we get that 2 sine squared of 2x is equal to 1 minus cosine of 4x. That means that sine squared of 2x is equal to 1 minus cosine of 4x divided by 2. And we can return with this information into our integral, and we get 1/2 x plus 1/2 integral cosine 2x dx minus 1/8 integral of 1 minus cosine 4x dx. So this is then equal to, we can introduce the substitution that t is equal to 2x, and then differential of t is 2 differentials of x. Of course, 1/2 of dt is equal to dx. For this integral, we are going to use the substitution that u is equal to 4x and du is equal to 4dx. 1/4 du is then equal to dx. Of course, this integral can be written as an integral of dx minus an integral of cosine 4x dx. So this is then equal to x half plus 1 divided by 4 integral of cosine t differential of t minus x divided by 8 plus 1 divided by 32 integral of cosine u du. So this is then equal to 4 minus 1 over 8x plus 1 over 4 sine t plus 1 over 32 sine u plus an arbitrary constant c. So this is then equal to 3 divided by 8x plus 1 divided by 4 sine of 2x plus 1 divided by 32 sine of 4x and plus c. Problem number 37 is an integral of sine to the fourth power of x dx. This is equal to sine squared of x times sine squared of x dx, and this is equal to an integral of sine squared x times 1 minus cosine squared of x dx. This is equal to an integral of sine squared of x dx minus an integral of sine squared x cosine squared x dx. So this is then equal to, we are going to use the same trick as before and write that sine squared of x is equal to 1 minus cosine of 2x divided by 2. So this is then equal to an integral of 1 minus cosine of 2x divided by 2 dx minus 1 over 4 integral 2 sine x cosine x squared dx. So this is equal to 1/2 x minus 1/2 of the integral cosine 2x dx minus 1 over 4 integral of sine squared of 2x dx. And this is equal to x half minus 1 over 4 integral of cosine t dt. Of course, the substitution is that t is equal to 2x, and that means that 1/2 of the differential t is differential of x. And minus 1 over 4 integral of 1 minus cosine of 4x divided by 2 differential of x. So this is equal to x half minus 1 over 4 sine t minus 1 over 8 integral of dx plus 1 over 8 integral of cosine 4x differential of x. Substitution is that u is equal to 4x, and that means that dx is 1 over 4 differential of u. So this is then equal to x half minus 1 over 4 sine t minus 1 over 8x plus 1 divided by 32 integral of cosine u differential of u. This is equal to 4 minus 1 over 8x minus 1 over 4 sine t plus 1 over 32 sine u plus c, which is equal to 3 divided by 8x minus 1 over 4 sine of 2x plus 1 over 32 sine of 4x and plus c. Integral number 38 on our list is an integral of tg to the fourth power of x dx. Of course, this is the tan function to the fourth power of x dx, and that can be written as sine to the fourth power x divided by cosine to the fourth power x dx. Of course, area in which this integral is defined is for cosine of x different than 0, and that means that x has to be different than p half plus kp, where k is an integer. So this then can be written as an integral of sine squared of x divided by cosine squared of x times 1 minus cosine squared of x divided by cosine squared of x differential of x. So this is an integral of sine squared x divided by cosine squared of x, or 1 divided by cosine squared of x minus 1 differential of x. So we can use the substitution that t is equal to sine of x over cosine of x, and that means that the differential of t is equal to 1 divided by cosine squared of x dx. So this integral can then be written as sine x divided by cosine x, and that squared, times 1 divided by cosine squared of x dx minus an integral of sine squared of x divided by cosine squared of x dx, which is equal to an integral of t squared differential of t minus an integral of 1 minus cosine squared of x divided by cosine squared of x differential of x. So this is then equal to t to the power 3 divided by 3 minus an integral of dx divided by cosine squared of x plus an integral of dx, and that is equal to 1/3 of t cubed minus tan of x plus c, which is equal to 1/3 tan cubed of x minus tan of x plus c. Problem number 39 on our list is an integral of ctg to the 4th power of x dx. Of course, this is cot function to the 4th power of x dx. So this can be written as ctg squared of x times cosine squared of x divided by sine squared of x dx, and that is equal to an integral of cotangents squared of x times 1 minus sine squared of x divided by sine squared of x dx. This is equal to cotangent squared of x 1 divided by sine squared of x minus 1 differential of x, and that is equal to cotangent squared of x times 1 divided by sine squared of x differential of x minus integral of cotangents squared of x differential of x. We can introduce the substitution that t is equal to cotangents of x, and that means that the differential of t is negative 1 over sine squared of x differential of x. Of course, our integrals are then transformed, and we get negative integral of t squared differential of t minus an integral of cosine squared of x divided by sine squared of x dx, which is negative t cubed divided by 3 minus integral of 1 minus sine squared of x divided by sine squared of x differential of x. This is equal to negative t cubed divided by 3 minus integral 1 divided by sine squared of x differential of x plus integral of the differential of x, and that is equal to negative t cubed divided by 3 plus cotangents of x plus c, and that is equal to negative 1/3 cotangents cubed of x plus cotangents of x plus c. Problem number 40 on our list is an integral of cosine cubed x dx. This is equal to cosine squared of x times cosine of x dx, and that is equal to an integral of 1 minus sine squared of x cosine x dx. We can use the substitution that t is equal to sine of x, and then differential of t is cosine of x differential of x. So the integral is transformed into 1 minus t squared differential of t, which is equal to a differential of t under integral minus integral of t squared dt. So this is t minus t cubed divided by 3 plus c, which is equal to sine x minus 1/3 of sine cubed x plus c. Problem number 41 is integral of sine to the 5th power of x dx. So this is equal to sine x times sine squared of x and that to the 2nd power dx. So this is then equal to an integral of sine x, 1 minus cosine squared of x squared, the differential of x, and that is by the substitution cosine of x is t, differential of t minus sine x dx. So this is then a negative integral of 1 minus t squared to the 2nd power dt. So this is then equal to negative integral of 1 minus 2t squared plus t to the 4th power differential of t. So this is negative integral of dt plus 2 integrals of t squared dt minus an integral of t to the 4th power dt. So this is equal to negative t plus 2 divided by 3t cubed and minus t to the 5th power divided by 5 plus c. So this is negative cosine of x plus 2 divided by 3 cosine cubed of x minus 1 over 5 cosine to the 5th power of x and plus c. Problem number 42 on our list is an integral of sine 5x times sine 3x dx. This integral we are going to solve using the trigonometrical equation to transform the product into a sum. So cosine, and since we have sine and sine, we are going to use the cosine of alpha plus beta. So this is equal to cosine alpha cosine beta minus sine alpha sine beta. So cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. We have double signs, so we are going to subtract these two equations. So this is cosine of alpha plus beta minus cosine of alpha minus beta, which is equal to negative 2 sine alpha sine beta. So sine alpha sine beta is then equal to negative 1/2 of the cosine alpha plus beta minus cosine of alpha minus beta. So sine 5x sine 3x is equal to negative 1/2 of the cosine of 8x minus cosine of 2x. Of course, this is equal to 1/2 of the cosine 2x minus cosine of 8x. So the integral is then transformed into 1/2 of the integral cosine 2x dx minus 1/2 of the integral cosine 8x dx, using the substitution that t is equal to x and u is equal to 8x. So differential of t is 2 differential of x and 1/2 of the differential t is differential of x. Differential of u is 8 differential of x. 1/8 of the differential of u is differential of x. These integrals are transformed into 1 over 4 integral cosine t dt minus 1 over 16 integral cosine u du. So this is equal to 1 over 4 sine t minus 1 over 16 sine u plus c. So this is equal to 1 over 4 sine 2x minus 1 over 16 sine 8x and plus c. Problem number 43 on our list is an integral of cosine 4x cosine x dx. So cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. When we add these two equations, we get that cosine of alpha plus beta plus cosine of alpha minus beta is equal to 2 cosine alpha cosine beta. That means that cosine alpha cosine beta is equal to 1/2 of the cosine alpha plus beta plus cosine of alpha minus beta. So cosine 4x cosine x is equal to 1/2 of cosine 5x plus cosine 3x. So this integral is then transformed into 1/2 of the integral cosine 5x dx plus 1/2 integral cosine 3x dx. Substitution is t is equal to 5x, differential of t is 5 dx, 1 over 5 dt is dx. Substitution u is equal to 3x, differential of u is 3 differential of x. So 1 over 3 differential of u is differential of x. This is then equal to 1 over 10 integral cosine t dt plus 1 over 6 integral cosine u du. So this is equal to 1 over 10 sine t plus 1 over 6 sine u plus c, which is equal to 1 over 10 sine 5x plus 1 over 6 sine 3x and plus an arbitrary constant c. Problem number 44 is an integral of sine 3x cosine 5x dx. Okay, sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. We can add these two equations and then we get that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine alpha cosine beta. So sine alpha cosine beta is equal to 1/2 of the sine alpha plus beta plus sine of alpha minus beta. So sine 3x cosine 5x is equal to 1/2 sine 8x plus sine of negative 2x. So this is equal to 1/2 sine 8x minus sine 2x. Sine function is an odd function, so a negative sign from an argument goes in front of the function. So our integral then becomes 1/2 of the integral sine 8x dx minus 1/2 the integral of sine 2x dx. Substitution, t is equal to 8x and then differential of t is 8 differential of x. 1 over 8 differential of t is differential of x. U is equal to 2x, du is 2 dx, so 1/2 of the differential of u is equal to differential of x. So this is equal to 1 over 16 integral sine t dt minus 1 over 4 integral of sine u du. So this is equal to negative 1 over 16 cosine of t plus 1 over 4 cosine of u plus c. So this is negative 1 over 16 cosine of 8x plus 1 over 4 cosine of 2x and plus c. Problem number 45 on our list is an integral of sine x over 3 cosine of 2x over 3 dx. Area in which this integral is defined is the set of real numbers. We are going to use the trigonometrical identities sine alpha plus beta, which is equal to sine alpha cosine beta plus cosine alpha sine beta, and the trigonometrical identity sine of alpha minus beta, which is sine alpha cosine beta minus cosine alpha sine beta. When we add these two equations together, we get that sine alpha plus beta plus sine alpha minus beta is equal to 2 sine alpha cosine beta. That means that sine alpha cosine beta is equal to 1/2 of the sum of sine alpha plus beta and sine alpha minus beta. When we plug the values sine x over 3 and cosine of 2x over 3 into this equation, we get 1/2 of the sine of x over 3 plus 2x over 3 and plus sine of x over 3 minus 2x over 3. This is equal to 1/2 of the sine x plus sine of negative x over 3. As sine is an odd function, 1/2 sine of x will be equal minus sine of x over 3. Sine is an odd function, so minus from the argument can go outside of the function. When we return this result into integral which we had in the beginning, we get that this is equal to 1/2 of the integral of sine x dx minus 1/2 of the integral sine x over 3 dx. This is then equal to negative 1/2 of the cosine of x minus 1/2 times 3 integral sine of t differential of t. Of course, we use a substitution that t is equal to x over 3, and that means that the differential of t is 1/3 of the differential of x. That means that 3 differentials of t is equal to differential of x. So this is then equal to negative 1/2 of the cosine of x plus 3/2 cosine of t and plus an arbitrary constant c. Finally, this is equal to negative 1/2 of the cosine of x plus 3/2 of the cosine of x over 3 and plus an arbitrary constant c. Problem number 46 on our list is an integral of sine x sine 2x sine 3x differential of x. This integral is defined in the set of real numbers. We can use the following trigonometrical identities to solve this integral. So cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. We can subtract these two equations from one another, and we get that cosine of alpha plus beta minus cosine of alpha minus beta is equal to negative 2 sine alpha sine beta. Well, that means that sine alpha sine beta is equal to negative 1/2 of the cosine alpha plus beta minus cosine of alpha minus beta. In our problem we have sine x times sine 2x, so this is equal to negative 1/2 of the cosine x plus 2x minus cosine of x minus 2x. This is then equal to negative 1/2 of the cosine of 3x and minus cosine of negative x. This is equal to negative 1/2 cosine of 3x minus cosine of x. Cosine is an even function, so this minus from the argument has no effect on the value of the function. This is finally equal to negative 1/2 of the cosine of 3x plus 1/2 of the cosine of x. When we return into the integral which we started from, it gets transformed into negative 1/2 of the cosine 3x plus 1/2 of the cosine x and times sine of 3x differential of x. This is then equal to negative 1/2 of the integral cosine 3x sine 3x differential of x plus 1/2 of the integral of cosine x sine 3x differential of x. To solve these two integrals, we are going to use the trigonometrical identities for sine alpha plus beta and sine alpha minus beta. The first one is equal to sine alpha cosine beta plus cosine alpha sine beta, and the second one is equal to sine alpha cosine beta minus cosine alpha sine beta. We are going to add these two equations together, and we get that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine alpha cosine beta. So sine alpha cosine beta is equal to 1/2 of the sine alpha plus beta and plus sine of alpha minus beta. In the first integral we have sine 3x cosine 3x, and that is going to be equal to 1/2 of the sine 3x plus 3x and plus sine of 3x minus 3x. This is equal to 0 and sine of 0 is 0, so we have just 1/2 of the sine of 6x. In the second integral, we have sine 3x and cosine x. This is going to be equal to 1/2 of the sine 3x plus x plus sine of 3x minus x. So this is equal to 1/2 of the sine 4x and plus sine of 2x. When we return all of this into our problem, it becomes negative 1/4 of the integral of sine 6x dx plus 1/4 of the integral of sine 4x plus sine of 2x differential of x. So this is negative 1/4 of the integral sine 6x differential of x plus 1/4 of the integral sine 4x dx plus 1/4 of the integral sine 2x differential of x. We can use the substitution that t is equal to 6x and then differential of t is 6 differentials of x. 1 over 6 differential of t is equal to the differential of x. U is equal to 4x is the substitution for this integral, and then differential of u is equal to 4 differentials of x. 1/4 of the differential of u is equal to the differential of x. And for the last integral, the substitution is v is equal to 2x, and then differential of v is equal to 2 differentials of x. 1/2 of the differential of v is equal to the differential of x. So then we get minus 1 over 24 integral of sine t differential of t plus 1 over 16 integral of sine u differential of u and plus 1 over 8 integral of sine v differential of v. This is then equal to 1 over 24 cosine of t minus 1 over 16 cosine of u minus 1 over 8 cosine of v plus an arbitrary constant c. When we return the substitution, we get 1 over 24 cosine of 6x minus 1 over 16 cosine of 4x and minus 1 over 8 cosine of 2x and plus c. So problem number 47 on our list is an integral of x squared dx over a cubic root of 1 plus x cubed. Area in which this integral is defined is for 1 plus x to the power 3 different than 0. That means that x cubed has to be different than negative 1, and that means that x has to be different than negative 1. So the area in which this integral is defined is the set of real numbers except the dot negative 1. We are going to solve this integral using a substitution that t is equal to 1 plus x cubed. Differential of t is then equal to 3x squared the differential of x, and using this substitution our integral gets transformed into 1 over 3 integral of the differential of t divided by a cubic root of t. So this is equal to 1/3 of the integral of t to the power negative 1/3 of differential of t. So this is equal to 1 over 3 times t to the power negative 1 over 3 plus 1 divided by 2 over 3 and plus an arbitrary constant c. This is equal to 1 over 3 times 3 over 2 times a cubic root of t squared. And plus c. So this is equal to 1/2 times a cubic root of 1 plus x cubed and then squared and plus a constant c. Problem number 48 on our list is an integral of the square root of 1 plus ln of x divided by x differential of x. So area in which this integral is defined is for 1 plus ln of x larger or equal to 0, and x has to be strictly larger than 0, and x has to be different from 0. So ln of x has to be larger or equal from negative 1, and that means that x has to be larger or equal to 1 over e. That makes our area in which this integral is defined from 1 over e to plus infinity, where 1 over e is included in the interval. We can solve this problem by using a substitution that t is equal to 1 plus ln of x, and that means that differential of t is equal to 1 over x differential of x. This integral is then transformed into an integral of the square root of t differential of t, and that is equal to t to the power 1/2 differential of t. This is t to the power 1/2 plus 1 divided by 3/2 and plus c. So this is equal to 2/3 times t to the power 3/2 plus c, which is 2/3 of a square root of t cubed plus c. Finally, this is equal to 2/3 of the square root of 1 plus ln of x cubed and plus c. Problem number 49 on our list is an integral of the cubic root of x cubed minus 8 times x squared dx. So area in this integral is defined as set of all real numbers, and we can solve it by using the substitution that x cubed minus 8 is equal to t. Differential of t is then equal to 3x squared differential of x, and that is going to transform the integral which we started with to 1 over 3 integral of the cubic root of t differential of t. So this is equal to 1 over 3 integral of t to the power 1 over 3 differential of t. This is then equal to 1 over 3 times t to the power 1 over 3 plus 1 divided by 1 over 3 plus 1 and plus c. So this is equal to 1 over 3 times t to the power 4 over 3 divided by 4 over 3 and plus c. This is equal to 1 over 3 times 3 over 4 times a cubic root of t to the 4th power and plus c, which is finally equal to 1 over 4 the cubic root of x to the power 3 minus 8 to the power 4 and plus an arbitrary constant c. Problem number 50 on our list is an integral of the cubic root of 1 minus 6x to the 5th power x to the 4th power dx. Area in which this integral is defined is set of all real numbers. We are going to use the substitution that t is equal to 1 minus 6x to the 5th power, and then differential of t is equal to negative 30x to the 4th power differential of x. This is then equal to negative 1 over 30 integral of the cubic root of t differential of t. So this is negative 1 over 30 integral of t to the power 1 over 3 differential of t, which is then equal to negative 1 over 30 times t to the power 1 over 3 plus 1 divided by 1 over 3 plus 1 and plus c. So this is negative 1 over 30 times t to the power 4 over 3 divided by 4 over 3 and plus c. This is equal to negative 1 over 30 times 3/4 times a cubic root of t to the 4th power and plus c. So this is equal to negative 1 over 40 times a cubic root of 1 minus 6x to the 5th power and that to the 4th power plus c. So the problem number 51 on our list is an integral of x dx over a square root of 3 minus x to the 4th power. Area in which this integral is well defined is for 3 minus x to the power 4 strictly larger than 0. That means that 3 is strictly larger than x to the power 4, x to the power 4 is smaller than 3, and that means that under the absolute value x has to be smaller than the 4th root of 3. So that means that x has to be between negative 4th root of 3 and the 4th root of 3 positive. So area in which this integral is defined is an open interval from negative 4th root of 3 to the positive 4th root of 3. We are going to solve this integral by using a substitution that t is equal to x squared. That means that differential of t is equal to 2x differential of x. So this integral is then transformed into 1/2 of the integral of dt over a square root of 3 minus t squared. This is equal to 1/2 times differential of t over a square root of 3 times another square root, where we are left with 1 minus t over a square root of 3, and that is going to be squared. So this is then equal to 1 over 2 square roots of 3 times an integral of differential of t over a square root of 1 minus t over square root of 3, and that is squared. So we can use a substitution that u is equal to t over square root of 3. Then differential of u is equal to 1 over a square root of 3 differential of t, and this integral is transformed into 1/2 of the integral of du over a square root of 1 minus u squared. Well, this is then equal to 1/2 of the arcus sine of u and plus some arbitrary constant c. And when we return the substitution, we get 1/2 of the arcus sine of t over a square root of 3 plus c. And when we return the substitution again, we get 1/2 of the arcus sine of x squared divided by a square root of 3 plus an arbitrary constant. Problem number 52 on our list is an integral of x squared differential of x divided by 4 plus x to the power 6. This integral is defined on the set of real numbers. We can solve this integral by using a substitution that t is equal to x cubed, and that means that the differential of t is equal to 3x squared, the differential of x. This integral is then transformed into 1 over 3 integral of dt over 4 plus t squared. So this is then equal to 1 over 3 integral of the differential of t over 4, and in brackets we have a 1 plus t half squared. So this is then equal to, we are going to use the substitution that u is equal to t half, and then we get that the differential of u is equal to 1/2 of the differential of t. So this integral is transformed into 1 over 12 integral of 2 differentials of u divided by 1 plus u squared. So this is then equal to 1 over 6 arcus tan of u and plus an arbitrary constant c. So this is 1 over 6 arcus tan of u was t half and plus c. When we return the substitution again, we get 1 over 6 arcus tan of x cubed divided by 2 and plus some arbitrary constant c. Now problem number 53 on our list is an integral of 4x minus 5 divided by x squared plus 5 differential of x. Area in which this integral is defined is an entire set of real numbers, and we can solve this by introducing the substitution that t is equal to x squared plus 5. That means that differential of t is equal to 2x dx. This integral is then transformed into two integrals, 4x dx divided by x squared plus 5 and minus 5 integral of dx over x squared plus 5. This is then equal to 2 integrals of dt over t minus 5 integrals of dx divided by 5, and in brackets we have 1 plus x over a square root of 5, and that entire quantity squared. So this is then equal to. We can solve this integral by using a substitution that u is equal to x over a square root of 5, and that means that the differential of u is 1 over a square root of 5 differential of x. Of course, that puts differential of x to be a square root of 5 du. So this is then equal to 2 times ln of the absolute value of t minus a square root of 5 integral of du divided by 1 plus u squared. This is equal to 2 ln of the absolute value of t minus a square root of 5 arcus tan of u and plus an arbitrary constant c. So this is equal to 2 times ln, and t was x squared plus 5, which is always positive, so we can omit the absolute value, and minus a square root of 5 arcus tan of x over a square root of 5 and plus some arbitrary constant c. Now problem number 54 on our list is an integral of x to the power 4 dx divided by x squared plus 2. This integral is defined for all real numbers. We can solve this integral by dividing these two polynomials. So x to the power 4 divided by x squared plus 2. We have x squared. X squared times x squared is x to the power 4, and x squared plus 2 is 2x squared. We can subtract this from the x to the power 4, and then we get negative 2x squared. Negative 2x squared divided by x squared is negative 2. Negative 2 times x squared is negative 2x squared, and negative 2 times positive 2 is negative 4. And when we subtract this again from the negative 2x squared, we just get 4. So this then can be written as x to the power 4 divided by x squared plus 2. The whole part which we get by this division is x squared minus 2, and the remainder is 4. So 4 plus x squared plus 2. This integral is then transformed into an integral of x squared minus 2 plus 4 over x squared plus 2, and then differential of x. We can write this as x cubed divided by 3 minus 2x and plus 4 integrals of dx. We can take 2 as common, and we are left with 1 plus x over a square root of 2, and then that quantity squared. So this is equal to x to the power 3 divided by 3 minus 2x plus 2 integrals of dx divided by 1 plus x over square root of 2 squared. We can introduce the substitution that t is equal to x over a square root of 2, and then the differential of t is equal to 1 over a square root of 2 dx. So this is then equal to x cubed divided by 3 minus 2x plus 2 integrals of the square root of 2 differential of t divided by 1 plus t squared. And that is then equal to x cubed divided by 3 minus 2x plus 2 square roots of 2 arcus tan of t and plus some arbitrary constant c. When we return the substitution, of course, we get x cubed divided by 3 minus 2x plus 2 square roots of 2 arcus tan, and t was defined as x divided by a square root of 2 and plus c. Problem number 55 on our list is an integral of 4 to the power x differential of x divided by a square root of 1 minus 4 to the power 2x. Okay, 1 minus 4 to the power 2x, for this to be well defined, has to be larger than 0. So 1 is larger than 4 to the power 2x. 4 to the power 2x is smaller than 1, and that means that ln of 4 to the power 2x has to be smaller than ln 1. So 2x ln 4 is smaller than 0, and that means that x has to be smaller than 0. Area in which this integral is defined is from negative infinity to 0 open interval. We can solve this integral by introducing the substitution that t is equal to 4 to the power x, and then differential of t is equal to 4 to the power x times ln 4 differential of x. This integral is then transformed into an integral differential of t divided by ln 4 times 1 over a square root of 1 minus t squared. So this is then equal to 1 over ln 4 integral of dt over a square root of 1 minus t squared, and that is just 1 over ln 4 times arcus sine of t plus some arbitrary constant c. So this is 1 over ln 4 arcus sine of t, which was 4 to the power x, and plus c. Now problem number 56 on our list is an integral of x differential of x divided by x to the 4th power plus 0,25. So area in which this integral is defined is the set of all real numbers, and we can solve this by using the substitution that t is equal to x squared. That means that the differential of t is equal to 2x differential of x, and that means that 1/2 of the differential of t is equal to x differential of x. When we return this into the integral which we started from, we get 1/2 of the integral of differential of t divided by 0,25 plus t squared. So this is equal to 1/2 times the integral of dt divided by 0,25, and in bracket we have 1 plus t over a square root of 0,25, and that quantity squared. So this is equal to 1/2 times an integral of dt over 1/4 times 1 plus t over a square root of 1/4, and that is squared. So this is 1/2 times 4 integrals of the differential of t divided by 1 plus 2t squared. So this is then equal to 2 integrals of dt divided by 1 plus 2t squared. And of course we can use the substitution that u is equal to 2t. That means that du is 2 differentials of t, and that is transformed into an integral of du over 1 plus u squared. So this is arcus tan of u and plus some arbitrary constant c. This is arcus tan of u is 2t plus c, and this is arcus tan of 2 times x squared and plus c. Now problem number 57 on our list is an integral of the differential of x divided by x squared plus a squared. Area in which this integral is defined is for x squared plus a squared larger than 0, and that means that x squared has to be larger than a negative a squared. So first option when solving this integral is for a to be equal to 0. So we have differential of x divided by a square root of x squared. This is going to be equal to the differential of x divided by an absolute value of x, and that is equal to dx over x signum function of x. Signum function of x is defined as 1 for all x's which are positive numbers, 0 for x is 0, and negative 1 for x's which are negative numbers. So this can be then written as a signum of x, because the function signum of x can be treated as a constant. So remember, a in this case is equal to 0, x squared is larger than a negative a squared, so x has to be larger than 0, or x has to be smaller than 0, times a differential of x over x into the integral sign, and we have signum of x times ln of the absolute value of x plus c. Of course, area in which this integral is defined for a is equal to 0 is the set of real numbers without the dot 0. This is for x. Now the second case for this problem is for a, which is different than 0. In this case, integral is defined for all real numbers. And of course, we are solving the integral of dx over a square root of x squared plus a squared. We can solve this integral by using a substitution that square root of x squared plus a squared is equal to t minus x. If we square this equation, we get that x squared plus a squared is equal to t squared minus 2tx and plus x squared. That means that a squared is equal to t squared minus 2tx, and that means that a squared minus t squared over 2t negative is equal to x. Well, that basically means that x is equal to t squared minus a squared over 2t. Differential of x is in this case going to be 4t squared minus 2t squared minus a squared in brackets divided by 4t squared differential of t. So this is 4t squared minus 2t squared plus 2a squared divided by 4t squared differential of t, and that is going to leave us 2t squared minus plus 2a squared divided by 4t squared the differential of t. This integral is then transformed into an integral of 2t squared plus 2a squared divided by 4t squared differential of t over a t minus t squared minus a squared over 2t. So this is then equal to an integral of 2t squared plus a squared divided by 4t squared over 2t squared minus t squared plus a squared divided by 2t differential of t. So this is then going to be equal to an integral of 2t times 2 brackets t squared plus a squared over 4t squared t squared plus a squared differential of t. So when this cancels out, we have just integral from dt over t, which is an ln of the absolute value of t and plus some arbitrary constant c. So this is then equal to ln of the absolute value of x plus a square root of x squared plus a squared and plus some arbitrary constant c. Now problem number 59 is an integral of dx divided by a square root of b squared x squared minus a squared. So this is going to be solved using the previous problem number 58. So we are going to say that t is equal to bx, and then differential of t is equal to b differential of x. This is transformed into 1 over b integral of differential of t divided by a square root of t squared minus a squared. This is then equal to 1 over b ln of the absolute value of t plus a square root of t squared minus a squared and plus an arbitrary constant c, which is 1 over b ln of the absolute value bx plus a square root of b squared x squared minus a squared and plus some arbitrary constant c. Problem number 60 on our list is an integral of dx divided by b squared plus a squared x squared. So this is then equal to an integral of dx over b squared, and in brackets we have 1 plus ax over b squared. So we can introduce the substitution that ax over b is equal to t, and that means that a over b differential of x is equal to differential of t. Well, this is then equal to 1 over b squared integral b over a times differential of t divided by 1 plus t squared. So this is then equal to 1 over ab integral of dt over 1 plus t squared, and this is just 1 over ab arcus tan of t plus an arbitrary constant c. So this is just equal to 1 over ab arcus tan of ax divided by b and plus some arbitrary constant c. Problem number 61 on our list is an integral of 3x plus 1 divided by a square root of 5x squared plus 1 differential of x. This integral is defined for all real numbers, and it can be written as an integral of 3x differential of x divided by a square root of 5x squared plus 1 and plus an integral of the differential of x divided by a square root of 5x squared plus 1. We are going to introduce the substitution that t is equal to 5x squared plus 1, and then differential of t is equal to 10x differential of x. dt over 10 is then equal to x dx. So this is then equal to 3 over 10 integrals of dt over a square root of t and plus an integral of dx divided by a square root of 5x squared and then plus 1. So this is going to be solved by using a substitution that u is equal to square root of 5x and then du is equal to a square root of 5 dx. du over a square root of 5 is then equal to dx. So this is equal to 3 over 10 integral of t to the power negative 1/2 dt and plus 1 over a square root of 5 integral of du over a square root of 1 plus u squared. So this is equal to 3 over 10 times t to the power negative 1/2 plus 1 divided by 1/2 and plus 1 over a square root of 5 of ln under the absolute value. We have u plus a square root of 1 plus u squared and plus c. So this is equal to 3 over 10 times 2 square roots of t and plus 1 over a square root of 5 ln of the absolute value of square root of 5x plus a square root of 1 plus 5x squared and plus c. So this is equal to 3 over 5 square root of 1 plus 5x squared and plus 1 over square root of 5 ln of the absolute value square root of 5x plus a square root of 1 plus 5x squared and plus c. Problem number 62 on our list is an integral of x plus 3 divided by a square root of x squared minus 4 differential of x. This integral is defined for x squared minus 4 larger than 0, x squared is larger than 4, and that means that under the absolute value x has to be larger than 2. So that means that x has to be smaller than a negative 2, or x has to be larger than 2, which gives us an area of negative infinity to negative 2, open set union an open set from 2 to positive infinity. This integral is then equal to an integral of x dx over a square root of x squared minus 4 and plus 3 integrals of dx divided by a square root of x squared minus 2 squared. So this can be then transformed by using a substitution that t is equal to x squared minus 4. Differential of t is 2x differential of x, and 1/2 of the differential of t is x dx. So this is then equal to 1/2 of the integral dt over a square root of t plus 3 ln the absolute value of x plus a square root of x squared minus 4 and plus c. So this is equal to 1/2 integral t to the power negative 1/2 differential of t and plus 3 ln. Under the absolute value we have x plus a square root of x squared minus 4 and plus c. So this is equal to 1/2 times t to the power negative 1/2 plus 1 over 1/2 and plus 3 ln under the absolute value x plus a square root of x squared minus 4 plus c, which is equal to a square root of t, which is a square root of x squared minus 4 and plus 3 ln of the absolute value of x plus x squared minus 4 under the square root and plus an arbitrary constant c. Problem number 63 on our list is an integral of the arcus tan of y divided by 1 plus y squared, the differential of y. We can solve this integral by using the substitution that t is equal to arcus tan of y, and then differential of t is equal to 1 over 1 plus y squared, the differential of y. Of course, area in which this integral is defined is an entire set of real numbers. So this is then equal to an integral of t differential of t, which is 1/2 of t squared plus c, and this is just 1/2 of the arcus tan squared of u and plus an arbitrary constant c. Problem number 64 on our list is an integral of 2 to the power of arcus tan of x divided by 1 plus x squared, the differential of x. Integral is defined on an entire set of real numbers, and we are going to use the substitution that t is equal to arcus tan of x. Differential of t is then equal to 1 over 1 plus x squared, the differential of x. This integral is then transformed into an integral of 2 to the power t differential of t, and this is just 2 to the power t divided by ln of 2 and plus an arbitrary constant c. So this is equal to 2 to the power arcus tan of x divided by ln of 2 and plus c. Problem number 65 on our list is an integral of dx divided by arcus sine of x times a square root of 1 minus x squared. This integral is defined for 1 minus x squared strictly larger than 0 and arcus sine of x different from 0. So this means that x squared has to be smaller than 1, and that means that negative 1 is smaller than x, which is smaller than 1, and x has to be different from 0. That means that area in which this integral is defined is from negative 1 to 0, open interval union from 0 to 1, again open interval. We can solve this problem by using a substitution that t is equal to arcus sine of x, and that means that the differential of t is equal to 1 over a square root of a 1 minus x squared, the differential of x. So this integral is then transformed into an integral of dt over t, which is ln of the absolute value of t and plus an arbitrary constant c. So this is ln of the absolute value of arcus sine of x and plus some arbitrary constant c. Problem number 66 on our list is an integral of arcus sine of x squared divided by a square root of a 1 minus x squared, differential of x. This integral is defined for 1 minus x squared strictly larger than 0, and that means that x is between a negative 1 and 1. Of course, area in which this integral is defined is an open interval from negative 1 to 1. This integral can be solved using a substitution that t is equal to arcus sine of x, and that means that the differential of t is 1 over a square root of 1 minus x squared, differential of x. This is then equal to an integral of t squared dt, which is t cubed divided by 3 plus c. When we return the substitution, that is 1/3 of the arcus sine cubed of x and plus an arbitrary constant c. Problem number 67 on our list is an integral of dx over x square root of 1 plus x squared. In order for this integral to be well defined, x has to be different than 0. So the area in which this integral is well defined is set of all real numbers except 0. We are going to solve this integral by using the substitution that x is equal to 1 over t. Differential of x is then equal to negative 1 over t squared, differential of t. This integral is then transformed into minus integral of dt divided by t squared times 1 over t times a square root of 1 plus 1 over t squared. This is equal to minus integral of dt over t square root of t squared plus 1 divided by t squared. This is then equal to minus integral of dt divided by t times 1 over the absolute value of t times a square root of t squared plus 1, and that is equal to negative differential of t divided by t over t times signum of t times a square root of t squared plus 1. We can treat signum of t function as a constant, so it can get in front of the sign of an integral. So we are left with the differential of t over a square root of 1 plus t squared. This is then equal to negative signum of t times an ln of the absolute value of t plus a square root of 1 plus t squared and plus some arbitrary constant c. This is then equal to negative signum of 1 over x times ln of the absolute value of 1 over x plus a square root of 1 plus 1 over x squared and plus c. Now I want to show you the second approach which we can use to solve this integral differential of x divided by x square root of 1 plus x squared. Again, area in which this integral is defined is set of all real numbers except 0. We can use the substitution that t is equal to a square root of 1 plus x squared, and that means that t squared is equal to 1 plus x squared, which means that x squared is equal to t squared minus 1. Differential of t is equal to 1 over 2 square roots of 1 plus x squared times 2x differential of x. Differential of t is then equal to x dx divided by a square root of 1 plus x squared. This integral which we have started from, we can write as an integral of x dx divided by x squared, a square root of 1 plus x squared. We have just multiplied by x the numerator and the denominator of this integral. Of course, we can do that. By that I mean multiplication with the denominator with x, because x has to be different than 0. So we have avoided dividing with 0. This integral is then equal to an integral of the differential of t divided by t squared minus 1, and that is an integral of dt over t minus 1 times t plus 1. 1 over t minus 1 t plus 1 can be written as a over t minus 1 plus b over t plus 1, and that is just equal to a t plus 1 plus b times t minus 1 over t minus 1 t plus 1. Well, that means that 1 is equal to t, and we have a plus b in brackets and plus a minus b outside of the brackets. So this means that a plus b has to be equal to 0 and a minus b has to be equal to 1. So that means that b is equal to negative a and 2a is equal to 1, which means that a is equal to 1/2. Well, that means that b is equal to negative 1/2. At this point, this integral gets transformed into 1/2 the integral of dt divided by t minus 1 minus 1/2 of the integral of dt divided by t plus 1. This is equal to 1/2 ln of t minus 1 minus 1/2 of the ln t plus 1. And of course plus c. So this is equal to 1/2 of the ln, and under the absolute value we have t minus 1 divided by t plus 1 and plus c. When we return the substitution, we get 1/2 of the ln of the absolute value 1 plus x squared under the square root minus 1 and 1 plus x squared under the square root and plus 1 and plus c. Of course, we can rewrite this as 1/2 times ln of the square root of 1 plus x squared minus 1 divided by a square root of 1 plus x squared and plus 1, and we can multiply this by a conveniently written 1. So that is 1 plus x squared minus 1 divided by a square root of 1 plus x squared minus 1 in this particular case. So this is 1/2 of the ln of the square root of 1 plus x squared minus 1, and that entire term squared, divided by 1 plus x squared minus 1 and plus c. So this is 1/2 of the ln of the square root of 1 plus x squared minus 1 squared divided by x squared and plus c. So this is equal to ln of the square root of 1 plus x squared under the square root minus 1 squared divided by x squared and plus c. So this is ln of the absolute value of 1 plus x squared minus 1 divided by x and plus c. The next problem on the list is problem 68, which is an integral of differential of x divided by x square root of x squared minus 2. For this integral to be well defined, x has to be different than 0 and x squared minus 2 has to be larger than 0. So x squared is larger than 2, and that means that x has to be from the interval from negative infinity to negative 2, union from t to positive infinity. So area in which this integral is defined is from negative infinity to negative 2, union from 2 to positive infinity. We can solve this integral by using the substitution that x is equal to 1 over t, and that means that the differential of x is minus 1 over t squared, the differential of t. This integral is then transformed into minus integral of dt over t squared times 1 over t times a square root of 1 over t squared minus 2, which is equal to negative integral of the differential of t divided by t a square root of 1 minus 2t squared divided by t squared. This is then equal to negative integral of the differential of t times 1 over the absolute value of t times a square root of 1 minus 2t squared. So this is then equal to negative signum of t times an integral of dt over a square root of 1 minus a square root of 2 times t, and that entire term squared. So this is equal to negative signum of t times an integral of du divided by a square root of 2 times the square root of 1 minus u squared. Of course, the substitution which we have used is that u is equal to a square root of 2t, and the differential of u is equal to a square root of 2 differential of t. So this is then equal to negative 1 over a square root of 2 signum of t times an integral of du divided by a square root of 1 minus u squared. This is negative 1 over square root of 2 signum of t times arcus sin of u and plus some arbitrary constant c. So this is equal to negative 1 over a square root of 2 signum of t times arcus sin of square root of 2 times t and plus c. So when we return the substitution, this is negative 1 over square root of 2 signum of 1 over x times arcus sin of square root of 2 times 1 over x and plus c. Problem number 69 on our list is an integral of the square root of 2 plus x squared minus a square root of 2 minus x squared divided by a square root of 4 minus x to the fourth power dx. So for this integral to be well defined, 2 plus x squared has to be larger or equal to 0, and 2 minus x squared has to be larger or equal to 0, and 4 minus x to the fourth power has to be strictly larger than 0. So this is 2 minus x squared times 2 plus x squared strictly larger than 0. So 2 plus x squared, that is always larger than 0, and 2 minus x squared has to be larger than 0. That means that x squared has to be smaller than 2. Well, that means that x is from the interval from negative square root of 2 to positive square root of 2. And then this integral is well defined in an area from negative square root of 2 to the positive square root of 2. We can solve this integral then by writing it in the form of two integrals. So we have 2 plus x squared under the square root divided by a square root of 4 minus x to the fourth power dx, and then minus an integral of square root of 2 minus x squared divided by a square root of 4 minus x to the fourth power dx. So this is then equal to an integral of square root of 2 plus x squared divided by square root of 2 minus x squared times square root of 2 plus x squared dx, minus an integral of square root of 2 minus x squared divided by a square root of 2 minus x squared times square root of 2 plus x squared dx. Of course, this two can cancel out and these two can cancel out. So we have an integral of dx divided by a square root of 2 minus x squared minus an integral of dx divided by a square root of 2 plus x squared. So this is then integral of dx divided by a square root of 2, and in brackets we have 1 minus x squared divided by 2, and minus an integral of dx divided by a square root of square root squared plus x squared. So this is then equal to 1 over square root of 2 times an integral of dx divided by a square root of 1 minus x half squared, x over the square root of 2 squared, minus an integral of dx divided by a square root of 2 to the second power plus x squared. So we can introduce the substitution here that t is equal to x over a square root of 2, and then differential of t is equal to 1 over square root of 2 differentials of x. So this is then equal to an integral of differential of t divided by a square root of 1 minus t squared. And this is minus an integral of dx over the square root of square root 2 squared plus x squared. And then this is equal to arcus sin of t and minus ln of the absolute value of x plus a square root of 2 squared and plus x squared and plus c. So this is arcus sin of x over a square root of 2 minus ln of absolute value of x plus a square root of 2 plus x squared and plus an arbitrary constant c. Problem number 70 on our list is an integral of e to the power arcus tan of x plus x ln of 1 plus x squared and plus 1 divided by 1 plus x squared differential of x. This integral is defined for all real numbers. It can be written as an e to the power arcus tan of x divided by 1 plus x squared dx plus an integral of x ln of 1 plus x squared divided by 1 plus x squared differential of x and plus an integral of the differential of x divided by 1 plus x squared. we can use the substitution that t is equal to arcus tan of x, and that means that differential of t is equal to 1 over 1 plus x squared the differential of x. U is equal to ln of 1 plus x squared, and that means that the differential of u is equal to 1 over 1 plus x squared times 2x differential of x. So du over 2 is equal to x dx over 1 plus x squared. This is then equal to an integral of e to the power t differential of t and plus integral of u times du over 2 and plus arcus tan of x, which is equal to e to the power t plus 1/2 of the u squared divided by 2 and plus arcus tan of x and plus an arbitrary constant c. So this is e to the power arcus tan of x plus 1 over 4 of ln of 1 plus x squared, and then entire term squared, and plus arcus tan of x and plus an arbitrary constant c. Problem number 71 on our list is an integral of sin x cosine of x divided by square root of 2 minus sine to the 4th power of x and then differential of x. This integral is defined on the entire set of real numbers, and we can use the substitution that t is equal to sine squared of x. Differential of t is then equal to 2 sine x cosine of x differential of x. So 1/2 of the differential of t is equal to sine x cosine x differential of x. This integral is then transformed into 1/2 of the integral of the differential of t divided by a square root of 2 minus t squared. This is 1/2 times an integral of differential of t divided by a square root of 2, and inside the brackets we have a 1 minus t over square root of 2, and that is squared. So this is then equal to 1 over 2 square roots of 2 integral of dt divided by a square root of 1 minus t divided by square root of 2, and that is squared, which is equal to 1 over 2 times integral of du divided by a square root of 1 minus u squared. We have used the substitution that u is equal to t over a square root of 2 in this step, so differential of u is then equal to 1 over a square root of 2 differential of t. This integral is then equal to 1/2 times arcus sin of u plus c, and when we return the substitution we get 1/2 of the arcus sin of t divided by a square root of 2 and plus c. And of course, when we return the substitution one more time, this is 1/2 of the arcus sin of sine squared of x divided by a square root of 2 and plus an arbitrary constant c. So problem number 72 on our list is an integral of arcus sin of x plus x divided by a square root of 1 minus x squared, differential of x. So this integral is that well defined for x from the interval from -1 to 1, and that is a closed interval. 1 minus x squared has to be strictly larger than 0, which means that 1 is strictly larger than x squared, so x has to be from an open interval from -1 to 1. This comes from arcus sin of x, and this comes because we have it under the square root, and that is in the denominator, so we cannot divide by 0. So area in which this integral is well defined is intersection of these two intervals, which is from -1 to 1 open interval. We can introduce the substitution that t is equal to arcus sine of x, and that means that differential of t is equal to 1 over a square root of 1 minus x squared, the differential of x. This integral is then transformed into an integral of arcus sin of x divided by a square root of 1 minus x squared, the differential of x, and plus an integral of x dx divided by a square root of 1 minus x squared. So this is then equal to an integral of t differential of t minus an integral. For this integral we can introduce the substitution that u is equal to a square root of 1 minus x squared. Differential of u is then equal to 1 divided by 2 square roots of 1 minus x squared times negative 2x differential of x. So du is equal to negative x dx over a square root of 1 minus x squared. This is then integral of the differential of u, and this is equal to t squared divided by 2 minus u and plus some arbitrary constant c. So this is then equal to 1/2 of the arcus sin of x squared arcus sin and minus a square root of 1 minus x squared and plus some arbitrary constant c. Problem number 73 on our list is an integral of arcus cosine of x minus x divided by a square root of 1 minus x squared, differential of x. Integral is defined in an area from -1 to 1 open interval. This is then equal to an integral of arcus cosine of x divided by a square root of 1 minus x squared differential of x and minus an integral of dx x dx divided by 1 minus x squared under the square root. We can use the substitution that t is equal to arcus cosine of x, and then differential of t is equal to negative 1 over a square root of 1 minus x squared dx. U is equal to a square root of 1 minus x squared is a substitution for the second integral, and we have that the differential of u is equal to 1 over 2 square roots of 1 minus x squared negative 2x dx. So differential of u is equal to negative x dx over a square root of 1 minus x squared. This is then equal to negative integral of t differential of t and plus an integral of the differential of u. So this is negative t squared over 2 and plus u plus c, which is equal to negative 1/2 of the arcus cosine squared of x and plus a square root of 1 minus x squared and plus some arbitrary constant c. Problem number 74. This is an integral of x minus arcus tan of x divided by 1 plus x squared differential of x. So this integral is defined on the set of real numbers, and we can rewrite it as x divided by 1 plus x squared differential of x minus an integral of arcus tan of x differential of x divided by 1 plus x squared. we can use the substitution that t is equal to 1 plus x squared, and then differential of t is equal to 2x differential of x. 1/2 of the differential of t is equal to x dx. U is equal to arcus tan of x, and differential of u is equal to 1 over 1 plus x squared differential of x. So this is equal to 1/2 of the integral of du of dt over t, and minus an integral of u du. So this is 1/2 of the ln of absolute value of t, and minus u squared divided by 2, and plus some arbitrary constant c. So this is 1/2 of the ln of absolute value of 1 plus x squared, minus 1/2 of the arcus tan squared of x, and plus c. So this is 1/2 of the ln. This is always positive, so we don't need the absolute value, minus 1/2 of the arcus tan squared of x, and plus some arbitrary constant c. Problem number 75 on our list is an integral of dx divided by 2 sine squared of x plus 3 cosine squared of x. So this integral can be written as an integral of dx divided by cosine squared of x, and in brackets we have 2 times sine squared of x divided by cosine squared of x, and plus 3. So this is then equal to an integral of dx divided by cosine squared of x, and we have 2 tan squared of x, and plus 3. So we can use the substitution that t is equal to tan of x, and then differential of t is 1 over cosine squared of x differential of x. So this integral then becomes an integral of the differential of t divided by 2t squared plus 3, which is equal to a differential of t under the integral sign, 3 of 1 plus 2t squared divided by 3. So this is then equal to 1/3 of the integral of differential of t divided by 1 plus square root of 2 t divided by a square root of 3 squared. And we can use the substitution that u is equal to square root of 2t divided by a square root of 3. So differential of u is a square root of 2 divided by a square root of 3 differential of t. Square root of 3 divided by a square root of 2 differential of u is equal to differential of t, and when we return this into an integral, we get 1 over 3 times a square root of 3 divided by a square root of 2, integral of du divided by 1 plus u squared. So this is equal to 1 over square root of 6 arcus tan of u plus c, which is equal to 1 over square root of 6 arcus tan of square root of 2 over 3 times t, and plus c. So this is 1 over square root of 6 arcus tan of square root of 2 over 3 times tan of x, and plus c. Problem number 76 on our list is an integral of a to the power x times e to the power x differential of x. This can be written as a times e, and that entire product on the power x differential of x. Well, this is equal to a times e to the power x divided by ln of a times e, and then plus some arbitrary constant c. Of course, this is equal to a to the power x times e to the power x divided by ln of a plus ln of e and plus c, which is equal to a to the power x times e to the power x divided by 1 plus ln of a and plus c. Of course, this integral is well defined for the entire set of real numbers. Problem number 77 on our list is an integral of dx divided by 1 plus x squared to the power 3 half. The area in which this integral is defined is the set of real numbers R. We can use the substitution that x is equal to tan of t in order to solve this integral, and of course t is going to be from the open interval from negative p half to p half. Differential of x is equal to 1 over cosine squared of t differential of t, and this integral is then going to be transformed into an integral of differential of t divided by cosine squared of t times 1 plus tan squared of t to the power 3 half. This is then going to be equal to an integral of dt divided by cosine squared of t times a square root of 1 plus sine squared of t divided by cosine squared of t. And that is going to be on the third power. So this integral is then equal to an integral of the differential of t divided by cosine squared of t times a square root of cosine squared of t plus sine squared of t divided by cosine squared of t, and that is going to be placed on the third power. So this is equal to an integral of differential of t divided by cosine squared of t times a square root of 1 over cosine to the sixth power of t. So this is then equal to differential of t divided by cosine squared of t times 1 over cosine cubed of t. So this is equal to an integral of dt over 1 over cosine of t. So this is equal to an integral of cosine of t differential of t. So this is then equal to sine of t and plus some arbitrary constant c. This can be written as sine of t divided by 1 and plus an arbitrary constant c, and we can rewrite this as sine of t divided by sine squared of t plus cosine squared of t, and we can put this under the square root and plus c. We can divide this by cosine of t because t is from the interval from negative p half to p half, and that means that cosine of t is strictly larger than 0. So this is then equal to sine of t divided by cosine of t divided by a square root of sine squared of t plus cosine squared of t divided by cosine of t and plus c. So this is then equal to tan of t divided by a square root of sine squared of t divided by cosine squared of t and plus cosine squared of t divided by cosine squared of t, which is equal to tan of t divided by a square root of tan squared of t plus 1, and when we return this, of course, plus c, the constants, and when we return the substitution, we get x divided by a square root of 1 plus x squared, and then plus an arbitrary constant c. Integral number 78 on our list is an integral of square root of a squared minus x squared dx. For this integral to be well defined, a squared minus x squared has to be larger or equal to 0, which means that a squared is larger or equal to x squared. x squared is smaller or equal than a squared, and that means that negative a under the absolute value has to be smaller or equal to x, and that has to be smaller or equal to a under the absolute value. So for a, which is strictly larger than 0, we get that x belongs in an interval from negative a to a. We can use the substitution that x is equal to a times sine of t, and then we get that the differential of x is a cosine of t dt. Of course, t is in this case from the closed interval from negative p half to p half, and by doing that we get that cosine of t is strictly larger than 0 or equal to it. Integral is then transformed into an integral of the square root of a squared minus a squared cosine a squared sine squared of t times a cosine t dt. So this is a square root of a squared 1 minus sine squared of t times a cosine of t dt. So this is then equal to a squared integral of the square root of cosine squared of t times cosine of t differential of t, and this is a squared times an integral of cosine squared of t differential of t. Cosine squared of alpha plus sine squared of alpha is equal to 1, and cosine squared of alpha minus sine squared of alpha is cosine of 2 alpha. When we add these two equations together, we get that 2 cosine squared of alpha is equal to 1 plus cosine of 2 alpha, and that means that cosine squared of alpha is equal to 1 plus cosine of 2 alpha divided by 2. So this is then equal to a squared times an integral of 1 plus cosine of 2t divided by 2 differential of t, and this is equal to a squared times 1/2 integral of differential of t and plus an 1/2 of the integral of cosine 2t differential of t. We can use the substitution that u is equal to 2t, and then we get that du is equal to 2 dt, and that means that 1/2 of the differential of u is equal to differential of t. So these integrals then become a squared times 1/2 t plus 1 over 4 integral of cosine u differential of u, which is equal to a squared divided by 2t plus a squared divided by 4 sine u and plus c. This is then equal to a squared divided by 2t plus a squared divided by 4 sine of 2t and plus c. So this is a squared divided by 2t plus a squared divided by 4 times 2 sine t cosine t and plus c. So this is a squared divided by 2t plus a squared divided by 2 sine of t square root of 1 minus sine squared of t and plus c. So this is equal to a squared divided by 2t plus a squared divided by 2 sine of arcus sine of x over a times a square root of 1 minus sine squared of arcus sine of x over a, and then plus c. So this is equal to, we see that x is equal to a sine t, and that means that sine t is equal to x over a, which means that t is equal to arcus sine of x over a. This is what we have used here. So this is equal to a squared divided by 2 arcus sine of x over a and plus a divided by 2 x square root of a squared minus x squared a squared divided by 2x over a. So I have here 1 minus x over a squared and plus c, which is equal to a squared divided by 2 times arcus sine of x over a and plus a divided by 2 times x square root of a squared minus x squared over a squared and plus c. So this is a squared over 2 arcus sine of x over a and plus ax divided by 2a square root of a squared minus x squared and plus c. So this is a squared over 2 arcus sine of x over a plus x over 2 square root of a squared minus x squared and plus c. Problem number 79. Integral of dx divided by x square root of a squared plus x squared. So this integral is well defined for x different than 0, and that means that area in which this integral is defined is set of all real numbers except the number 0. So this is then integral of x dx divided by x squared square root of x squared plus a squared. We can use the substitution that t is equal to a square root of a squared plus x squared, and then t squared is equal to a squared plus x squared, which means that x squared is equal to t squared minus a squared. Differential of t is equal to 1 over 2 square roots of a squared plus x squared, 2x differential of x, and that means that the differential of t is equal to x dx divided by a square root of a squared plus x squared. This integral then becomes an integral of differential of t divided by t squared minus a squared, which is equal to an integral of dt over t minus a times t plus a. So 1 over t minus a t plus a can be written as a divided by t minus a plus b divided by t plus a. So this is equal to a, we have t plus a plus b t minus a divided by t minus a t plus a. So we have that 1 is equal to t, and in brackets we have a plus b and plus a minus ba. So a plus b has to be equal to 0, and a minus b has to be equal to 1. That means that a plus b is equal to 0, and a minus b is equal to 1 over a. So 2a is equal to 1 over a, which means that a is equal to 1 over 2a, and b is equal to negative a, which means that b is equal to negative 1 over 2a. 1 over t minus a t plus a can then be written as 1 over 2a multiplied by 1 over t minus a minus 1 over 2a multiplied by 1 over t plus a. So this is then equal to an integral of 1 divided by 2a, 1 over t minus a minus 1 over t plus a differential of t. So this is equal to 1 over 2a integral of 1 divided by t minus a differential of t minus 1 over 2a integral of 1 divided by t plus a differential of t. So this is then equal to 1 over 2a. In brackets we have ln of the absolute value of t minus a minus ln of absolute value of t plus a and plus c. So this is equal to 1 over 2a ln of t minus a divided by t plus a and plus c. So this is 1 over 2a ln of the absolute value of x squared plus a squared under the square root minus a divided by a square root of x squared plus a squared and plus a and plus c. So this is equal to 1 over 2a ln of the absolute value of x squared plus a squared minus a squared divided by x squared plus a squared plus 2a square root of x squared plus a squared and plus a squared under the absolute value plus c. So this is 1 over 2a ln of the absolute value of x squared. So square root of x squared plus a squared and plus a, that is squared, and plus c. So this is 1 over a ln of square root of x squared divided by a square root of x squared plus a squared and plus a, that is squared, and plus c. So we get 1 over a ln of the absolute value of x divided by a square root of x squared plus a squared and plus a and plus c. Now the second approach we can use to solve this integral dx divided by x square root of a squared plus x squared is using the substitution that x is equal to a times tan of u. That means that differential of x is equal to a times 1 divided by cosine squared of u, differential of u. The square root of a squared plus x squared is then equal to a square root of a squared plus a squared tan squared of u, which is equal to a square root of a squared 1 plus tan squared of u, which is equal to a square root of 1 plus sine squared of u divided by cosine squared of u, which is equal to a times a square root of cosine squared of u plus sine squared of u divided by cosine squared of u. So this is a times 1 over cosine of u. Now area in which this integral is defined is set of real numbers except 0. So that means that this u has to be from the interval from negative p half to p half except the number 0. That is why we have here 1 over cosine of u without the absolute value. So the integral then becomes an integral of a divided by cosine squared of u times 1 over a times tan of u times cosine of u divided by a times differential of u. So this is equal to 1 over a integral of 1 over cosine of u tan of u differential of u. So this is 1 over a integral of 1 over cosine of u times cosine of u divided by sine of u du. This is equal to 1 over a times an integral of du over sine of u. And this is equal to 1 over a times ln of the absolute value of tan of u half and plus c. We know that tan of u half is equal to sine of u half divided by cosine of u half, and that is equal to 2 sine of u half times cosine of u half divided by 2 cosine squared of u half. So this is equal to sine of u divided by 2 cosine squared of u half. Cosine squared of u half plus sine squared of u half is equal to 1, and cosine squared of u half minus sine squared of u half is cosine of u. So when we add these two together, we get that 2 cosine squared of u half is equal to 1 plus cosine of u. So this is then equal to sine of u divided by 1 plus cosine of u. A square root of a squared plus x squared was a times 1 over cosine of u, and that means that cosine of u is equal to a divided by a square root of a squared plus x squared. X was substituted as a times tan of u, which means that tan of u is equal to x over a, and sine of u divided by cosine of u is equal to tan of u, which is just x over a. So that means that sine of u is equal to x over a cosine of u, which is equal to x over a times a over a square root of a squared plus x squared. This means that sine of u is equal to x over a square root of a squared plus x squared. So our integral then becomes 1 over a ln of absolute value of sine of u divided by 1 plus cosine of u and plus c, which is equal to 1 over a times ln of the absolute value of x divided by a square root of a squared plus x squared divided by 1 plus a over a square root of a squared plus x squared and plus c. So this is just 1 over a times ln of the absolute value of x divided by a square root of a squared plus x squared divided by a plus a square root of a squared plus x squared divided by a square root of a squared plus x squared and plus c. So this is 1 over a times ln of x square root of a squared plus x squared divided by a square root of a squared plus x squared, and in brackets we have a plus a square root of a squared plus x squared and plus c. So this is equal to 1 over a ln of x over a plus square root of a squared plus x squared and plus c. I have deliberately shown how to solve this integral in two different ways. What I want to show with this is that the solution of an integral is a unique family of primitive functions. So it doesn't matter which method you use to solve an integral, you are always going to get one and the same family of primitive functions. I.e., you can't get an integral which has two different solutions. Integral number 80 on our list is an integral of x squared dx divided by a square root of 9 minus x squared. So this integral is defined for 9 minus x squared strictly larger than 0, which means that x squared is smaller than 9. So this means that minus 3 is smaller than x and that is smaller than 3, which means that the area in which this integral is well defined is an open interval from -3 to 3. We can write this integral as an integral of 9 plus x squared minus 9 divided by a square root of 9 minus x squared dx. So this is then equal to 9 dx divided by a square root of 9 minus x squared and plus an integral of x squared minus 9 divided by a square root of 9 minus x squared dx. So this is then equal to 9 times an integral of dx divided by 3 a square root of 1 minus x over 3 squared and minus an integral of 9 minus x squared divided by a square root of 9 minus x squared dx. So this is equal to 3 times an integral of dx divided by a square root of 1 minus x over 3 squared and minus an integral of square root of 9 minus x squared dx. We can use the substitution that x over 3 is equal to t, and then we get that 1/3 of the differential of x is equal to differential of t. So this is then equal to 3 times an integral of 3 differential of t divided by a square root of 1 minus t squared. And minus this integral here is 9/2 of the arcus sin of x divided by 3 plus x half times the square root of 9 minus x squared and plus c. So this is equal to 9 arcus sin of t minus 9/2 arcus sin of x divided by 3 and minus x half times the square root of 9 minus x half and plus c. So this is equal to 9/2 of the arcus sin of x divided by 3 minus x half of the square root of 9 minus x squared and plus an arbitrary constant c. Problem number 81 on our list is an integral of x times the square root of a minus x differential of x. We are going to use the substitution that t is equal to a square root of a minus x, which means that t squared is a minus x, and that means that x is equal to a minus t squared. Differential of t is equal to 1 over 2 square roots of a minus x times negative 1 differential of x, and that means that the differential of x is equal to negative 2t differential of t. So this integral is then transformed into negative integral of a minus t squared times t times 2t differential of t. So this is equal to negative integral of at squared minus t to the 4th power differential of t, which is equal to negative 2a times t cubed divided by 3 plus 2 times t to the 5th power divided by 5 and plus c, which is equal to negative 2/3 a times the square root of a minus x cubed and plus 2 over 5 square root of a minus x to the 5th power and plus an arbitrary constant c. Problem number 82 on our list is an integral of sine cubed x cosine cubed x dx. This integral is defined for all real numbers. What we can do is write this integral as sine cubed x cosine squared x cosine x dx. We can use the substitution that t is equal to sine x, and that means that the differential of t is equal to cosine x dx. So this integral is then equal to sine cubed x, 1 minus sine squared of x and cosine x dx. This is equal to integral of t cubed 1 minus t squared differential of t. So this is an integral of t cubed minus t to the 5th power differential of t. So this is integral of t cubed dt minus integral of t to the 5 differential of t. So this is t to the 4th power divided by 4 minus t to the 6th power divided by 6 and plus an arbitrary constant c. So this is 1/4 of the sin cubed x of sin to the 4th power x minus 1 over 6 sin to the 6th power of x and plus c. Problem number 83 on our list is an integral of sine squared of x cosine to the 4th power of x dx. This integral is defined for all real numbers. We can write sine squared x cosine to the 4th power x as sine squared x times cosine squared of x times cosine squared of x, and this is equal to 1/4 of 2 sine x cosine x squared times cosine squared of x. This is then equal to 1/4 of sin squared of 2x times 1/2 of 1 plus cosine of 2x. This is equal to 1/8 sin squared of 2x 1 plus cosine of 2x. We can use that cosine squared x plus sine squared x is equal to 1, and cosine squared x minus sine squared of x is equal to cosine 2x. If we add these two equations, we get that 2 cosine squared of x is equal to 1 plus cosine of 2x, meaning that cosine squared of x is equal to 1 plus cosine 2x divided by 2. And if we subtract these two equations, we get that 2 sine squared of x is equal to 1 minus cosine of 2x, which means that sine squared of x is equal to 1 minus cosine of 2x divided by 2. So this term then becomes 1/8 sine squared of 2x plus 1/8 sine squared of 2x cosine of 2x, which is then equal to 1/8 times 1/2 of 1 minus cosine of 4x plus 1/8 sine squared of 2x cosine of 2x, which is equal to 1/16 minus 1/16 cosine of 4x plus 1/8 sine squared of 2x cosine of 2x. So the integral then becomes 1/16 integral dx minus 1/16 integral of cosine 4x dx plus 1/8 integral of sine squared of 2x cosine of 2x dx. We can use the substitution that t is equal to 4x, which means that differential of t is 4 differentials of x, and 1/4 of the differential of t is the differential of x. Using the substitution that u is sine of 2x, we get that differential of u is 2 cosine of 2x differential of x, meaning that 1/2 of the differential of u is cosine 2x differential of x. And then the integral becomes 1/16x minus 1/64 integral of cosine t differential of t and plus 1/16 integral of u squared differential of u. So this is 1/16x minus 1/64 sine t and plus 1/16 times u cubed divided by 3 and plus c. So this is 1/16x minus 1/64 sine 4x and plus 1/48 sine cubed of 2x and plus c. Problem number 84 is an integral of sine to the 4th power x cosine squared of x differential of x. This integral is defined for all real numbers. We can write this integral as an integral of sine squared x cosine squared x differential of x. So this is equal to an integral of 1/2 of 1 minus cosine of 2x, 1/4 of 2 sine x cosine x squared differential of x. So this is then equal to 1/8 integral of 1 minus cosine of 2x times sine squared of 2x differential of x. So this is 1 over 8 integral of sine squared of 2x differential of x minus 1 over 8 integral cosine of 2x sine squared of 2x differential of x. So this is 1 over 8 integral of 1/2 1 minus cosine of 4x differential of x minus 1 over 8 integral cosine 2x sine squared 2x differential of x. So this is 1 over 16 integral dx minus 1 over 16 integral cosine 4x differential of x minus 1 over 8 integral cosine of 2x sine squared of 2x differential of x. Substitution t is equal to 4x, which means that differential of t is equal to 4 differentials of x. 1 over 4 differential of t is equal to differential of x. We can use the substitution that u is sin 2x at this point, and the differential of u is 2 cosine 2x differential of x. So 1/2 of the differential of u is equal to cosine 2x differential of x. So this is then equal to 1 over 16x minus 1 over 64 integral cosine t differential t minus 1 over 16 integral u squared differential of u. So this is 1 over 16x minus 1 over 64 sine t minus 1 over 48 u cubed and plus an arbitrary constant c. So this is 1 over 16x minus 1 over 64 sine 4x minus 1 over 48 sine cubed of 2x and plus c. Problem number 85 on our list is an integral of sine cubed x cosine squared x differential of x. Again, area for this integral is the set of real numbers. We can use the substitution that t is equal to cosine x, and we get that the differential of t is negative sine x dx. So we get this to be equal to an integral of sine squared of x cosine squared of x sine of x differential of x, which is an integral of 1 minus cosine squared of x cosine squared of x sine of x differential of x, which is equal to an integral of 1 minus t squared differential of t, which is equal to negative integral of t squared minus t to the 4th power differential of t. I have minus here. So this is then equal to negative integral of t squared differential of t plus an integral of t to the 4th power differential of t, which is equal to negative t cubed divided by 3 and plus t to the 5th power divided by 5 and plus c. So this is negative 1/3 of the cosine cubed of x plus 1 over 5 cosine to the 5th power of x and plus some arbitrary constant c. Problem number 86 on our list is an integral of sin 3x cosine 5x differential of x. Again, this integral is defined for the set of real numbers. We know the trigonometrical identities that sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta, and we know that sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. When we add these two equations to one another, we get that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine alpha cosine beta. That means that sine alpha cosine beta is equal to 1/2 of the sine alpha plus beta and plus sine of alpha minus beta. So sine of 3x cosine of 5x is equal to 1/2 sine 3x plus 5x plus sine of 3x minus 5x, which is then equal to 1/2 sine of 8x minus sine of 2x. So this is minus 2x, and sine is an odd function, so minus from the argument goes in front of the function. The integral then becomes 1/2 of the integral sine 8x differential of x minus 1/2 integral sine 2x differential of x. Using the substitution that t is 8x and differential of t is 8 dx, so 1/8 differential of t is differential of x, and using the substitution that u is equal to x, which means that differential of u is 2 differentials of x, 1/2 of the differential u is differential of x. So we get 1/16 integral sine t differential of t minus 1/4 integral sine u differential u. So this is 1/16 negative cosine t minus 1/4 negative cosine u and plus some arbitrary constant c. So this is negative 1/16 cosine 8x plus 1/4 cosine of 2x and plus some arbitrary constant c. Problem number 87 is an integral of sine 2x cosine 3x differential of x. So we are going to use the same formula from the previous problem, and then we are getting that sine 2x cosine 3x is equal to 1/2 sine 5x minus sine x. We are going to rewrite this integral then as 1/2 the integral of sine 5x differential of x minus 1/2 the integral of sine x differential of x. We are going to use the substitution that t is equal to 5x, and that means that the differential of t is 5 differentials of x, meaning 1/5 dt is dx. So this integral then becomes 1/10 integral of sine t differential of t and plus 1/2 cosine x and plus c. So this is negative 1/10 cosine t and plus 1/2 cosine x and plus c. We finally get 1/10 negative cosine of 5x plus 1/2 cosine of x and plus some arbitrary constant c. So let's solve the problem number 88 on our list. Integral of cosine 7x cosine 3x differential of x. Of course, this integral is defined for set of real numbers r, and since we have a product of cosines, we are going to use the formulas for cosine alpha plus beta, meaning the cosine for the sum of two angles and cosine from the difference of two angles. So this is equal to cosine alpha cosine beta minus sine alpha sine beta, and this is cosine alpha cosine beta plus sine alpha sine beta. We are going to add these two equations to one another, and then we get that cosine of alpha plus beta plus cosine of alpha minus beta is equal to 2 cosine alpha cosine beta. So cosine alpha cosine beta is equal to 1/2 of the cosine of alpha plus beta plus cosine of alpha minus beta. So cosine of 7x cosine of 3x is equal to 1/2 cosine 10x plus cosine 4x. When we return this into the beginning problem, we get 1/2 the integral of cosine 10x differential of x plus 1/2 integral of cosine 4x differential of x. Substitution t is equal 10x and u is equal to 4x. Differential of t is 10 differentials of x, and 1 over 10 differential of t is equal to differential of x. Differential of u is 4 differentials of x. 1/4 of the differential of u is a differential of x. So this is then equal to 1 over 20 integral cosine t differential of t plus 1 over 8 integral cosine u differential of u, and then we get 1 over 20 sine t and plus 1 over 8 sine u and plus c. When we return the substitution, we get 1 over 20 sine 10x plus 1 over 8 sine 4x and plus an arbitrary constant c. Problem number 89 on our list is an integral of sine x sine 5x differential of x. Of course, this integral is well defined for the entire set of real numbers. Again, we use cosine of alpha plus beta as cosine alpha cosine beta minus sine alpha sine beta, and cosine of alpha minus beta as cosine alpha cosine beta plus sine alpha sine beta. This time we need product of signs, so this is that part, the right part of the equation. So we are going to subtract these two equations from one another, and we get cosine of alpha plus beta minus cosine of alpha minus beta is negative 2 sine alpha sine beta, and then sine alpha sine beta is equal to negative 1/2 of the cosine alpha plus beta minus cosine of alpha minus beta. That means that this is 1/2 of the cosine of alpha minus beta minus cosine of alpha plus beta. So sine x sine 5x is then equal to 1/2 cosine of 6x and minus cosine of negative 4x. Cosine is an even function, so minus doesn't make any difference in the argument. My mistake at this point. Sine x sine 5x is equal to 1/2 cosine negative 4x, so this is 4x minus cosine 6x. I have flipped them over by mistake. So the integral then becomes 1/2 the integral of cosine 4x differential of x minus 1/2 integral of cosine 6x differential of x. We can use the substitution that t is equal to 4x and u is equal to 6x. So differential of t is 4 differentials of x, or 1/4 of the differential of t is differential of x. Differential of u is 6 differentials of x, and 1 over 6 differential of u is differential of x. So this is then equal to 1 over 8 integral of cosine t differential of t minus 1 over 12 integral of cosine u du. So this is equal to 1 over 8 sine t minus 1 over 12 sine u and plus c. So this is 1 over 8 sine 4x minus 1 over 12 sine 6x and plus c. Problem number 90 on our list is integral of sin 7x cosine 3x differential of x. Again, integral is defined for the entire set of real numbers. So sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta, and sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. We are going to add these two equations, and then we get that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine alpha cosine beta, which means that sine alpha cosine beta is equal to 1/2 sine of alpha plus beta plus sine of alpha minus beta. That means that sine 7x cosine 3x is equal to 1/2 sine 10x and plus sine 4x. The integral can then be written as 1/2 integral of sine 10x differential of x and plus 1/2 integral of the sine 4x differential of x. We are going to use the substitution that t is equal to 10x, meaning differential of t is 10 differentials of x, or 1 over 10 differential of t is differential of x. U is equal to 4x, differential of u is 4 differentials of x, and 1/4 of the differential of u is differential of x. So this is equal to 1/2 times 1 over 10 integral sine t differential of t plus 1 over 8 integral of sine u differential of u, which is equal to negative 1 over 20 cosine t plus 1 over 8 negative cosine u and plus some arbitrary constant c. When we return the substitution, we get negative 1 over 20 cosine 10x minus 1 over 8 cosine 4x and plus an arbitrary constant c. Problem number 91 on our list is sine 5x sine 3x differential of x. Again, this integral is defined for set of real numbers. We know that cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And we know that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. We are going to subtract these two equations from one another, and we get that cosine of alpha plus beta minus cosine of alpha minus beta is equal to negative 2 sine alpha sine beta. What that means is that sine alpha sine beta is equal to negative 1/2 of the cosine of alpha plus beta minus cosine of alpha minus beta. So this is equal to 1/2 of the cosine of alpha minus beta minus 1/2 of the cosine of alpha plus beta. We have sine 5x sine 3x. This is equal to 1/2 the cosine of 2x minus 1/2 the cosine of 8x. The integral is then transformed into 1/2 of the integral of cosine 2x differential of x minus 1/2 the integral of cosine 8x differential of x. We are going to use the substitution that t is equal to 2x and u is equal to 8x. Differential of t is 2 differentials of x, and 1/2 of the differential of t is differential of x. Differential of u is equal to 8 differentials of x, which means that 1 over 8 differential of u is equal to differential of x. This is then equal to 1 over 4 integral of cosine t differential of t minus 1 over 16 integral cosine u du. So this is equal to 1/4 sine t minus 1 over 16 sine u and plus some arbitrary constant c. When we return the substitution, this is equal to 1/4 sine 2x minus 1 1 over 16 sine 8x and plus an arbitrary constant c. Problem number 92 on our list is an integral of sine 2x sine 5x differential of x. This integral is defined for the set of all real numbers. We know that cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. We also know that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. We are going to subtract these two equations from one another, and then we get that cosine of alpha plus beta minus cosine of alpha minus beta is equal to negative 2 sine alpha sine beta. This means that sine alpha sine beta is equal to negative 1/2 of the cosine of alpha plus beta minus cosine of alpha minus beta. So this is equal to 1/2 of the cosine of alpha minus beta and minus 1/2 of cosine of alpha plus beta. So sine of 2x sine 5x is equal to 1/2 of the cosine of negative 3x, which is equal to cosine of 3x, because cosine is an even function, and minus 1/2 cosine of 7x. The integral is then transformed into 1/2 of the integral of cosine 3x differential of x minus 1/2 of the integral of cosine 7x differential of x. We are going to use the substitution that t is equal to 3x. That it means that the differential of t is equal to 3 differentials of x. 1 over 3 dt is dx, and u is equal to 7x, differential of u is equal to 7 differentials of x, meaning 1 over 7 differential of u is equal to differential of x. So this is equal to 1 over 6 cosine t differential of t minus 1 over 14 integral cosine u differential of u, which is equal to 1 over 6 sine t minus 1 over 14 sine u and plus an arbitrary constant c. So this is 1 over 6 sine 3x minus 1 over 14 sine 7x and plus an arbitrary constant c. Problem number 93 on the list is an integral of dx divided by cosine to the 4th power of x. That means that cosine of x has to be different than 0, which means that x is different than p half plus kp, where k is an integer. Area in which this integral is defined is set of real numbers except the dots p half plus kp, where k is an integer. This integral can be written as an integral of dx divided by cosine squared of x times cosine squared of x, which is equal to 1 over cosine squared of x times differential of x divided by cosine squared of x. We are going to use the substitution that t is equal to tan of x, and that means that differential of t is equal to 1 over cosine squared of x differential of x. This is then equal to, so a 1 over cosine squared of x can be also written as sine squared of x plus cosine squared of x divided by cosine squared of x, and that is equal to sine squared of x divided by cosine squared of x plus cosine squared of x divided by cosine squared of x. So this is just 1 plus tan squared of x. So the integral is then equal to an integral of 1 plus tan squared of x, differential of x divided by cosine squared of x. So this is equal to an integral of a 1 plus t squared differential of t, which is equal to an integral of dt plus an integral of t squared differential of t. So this is t plus t cubed divided by 3 and plus c, which is equal to tan of x plus 1/3 tan cubed of x and plus an arbitrary constant c. Problem number 94 is an integral of sine squared x divided by cosine to the 6th power of x differential of x. Again, area in which this integral is defined is set of real numbers without the dots p half plus kp, where k is an integer. This integral can be written as an integral of sine squared x divided by cosine squared of x times 1 over cosine squared of x times 1 over cosine squared of x differential of x. We can use the substitution that t is equal to tan x, and that means that the differential of t is equal to 1 over cosine squared of x differential of x. 1 over cosine squared of x is equal to sine squared x plus cosine squared of x divided by cosine squared of x, and that is 1 plus tan squared of x, which is equal to 1 plus t squared. So the integral then becomes an integral of t squared, 1 plus t squared differential of t, and that is equal to an integral of t squared differential of t plus an integral of t to the 4th power differential of t, which is equal to t cubed divided by 3 plus t to the 5th power divided by 5 and plus an arbitrary constant c. So this is equal to 1 over 3 tan cubed of x plus 1 over 5 tan to the 5th power of x and plus an arbitrary constant c. Problem number 95. This is integral of dx divided by sine to the 4th power of x cosine to the 4th power of x. So this can be written as differential of x divided by 2 sine x cosine x, and that to the 4th power, times 1 over 16 to cancel the 2 to the 4th power. So this is then equal to 16 integral of the dx divided by sine to the 4th power of 2x. We are going to use the substitution that t is equal to 2x, and that means the differential of t is equal to 2 differentials of x. 1/2 of the differential of t is then equal to differential of x. The integral then becomes 8 times an integral of dt divided by sine to the 4th power of t, which is 8 times an integral of dt divided by sine squared of t cosine squared of t, and that is equal to 1 over sine squared of t. We are going to write as sine squared of t plus cosine squared of t divided by sine squared of t, and that is 1 plus cot of t squared. We are going to use the substitution that u is equal to cot of t, and that means that the differential of u is negative 1 over sine squared of t differential of t. So the integral then becomes 8 times an integral of 1 plus cot squared of t times differential of t divided by sine squared of t, and that is equal to negative 8 integrals of 1 plus u squared, the differential of u. So this is negative 8 integrals of the differential of u minus 8 integrals of u squared, the differential of u, which is minus 8u minus 8 times u cubed divided by 3 and plus c. So this is minus 8 cot t minus 8 divided by 3 cot cubed of t and plus c. So this is minus 8 cot 2x minus 8 divided by 3 cot cubed of 2x and plus an arbitrary constant c. Problem number 96. Integral sine to the fifth power of x divided by cosine squared x dx. So this can be written as sine to the fourth power of x times sine of x dx divided by cosine squared of x. So we are going to use the substitution that t is equal to cosine x, and that means that the differential of t is equal to negative sine of x differential of x. This is then equal to an integral of sine squared x, and that squared sine x differential of x divided by cosine squared of x. So this is equal to an integral of 1 minus cosine squared x, and that squared divided by cosine squared x sine x dx. This is then equal to negative integral of 1 minus t squared squared divided by t squared differential of t, which is equal to negative integral of 1 minus 2t squared and plus t to the fourth power divided by t squared differential of t. So this is then going to be equal to negative integral of 1 over t squared differential of t plus 2 integrals of the differential of t and minus an integral t squared differential of t. This is equal to negative t to the power negative 2 differential of t plus 2t minus t cubed divided by 3 and plus c. So this is equal to negative t to the power negative 2 plus 1 divided by minus 1 and plus 2t minus t cubed divided by 3 and plus c. So this is 1 over t plus 2t and minus 1/3 of the t cubed and plus c. So this is equal to 1 over cosine of x plus 2 cosine of x minus 1/3 of the cosine cubed of x and plus c. Problem number 97. Integral of cosine to the fifth power of x divided by sine squared of x differential of x. This integral is defined if and only if sine of x is different than 0, which means that x has to be different from kp, where k is an integer. So area in which this integral is defined is set of real numbers without the dots kp, where k is an integer. So we can write this integral as an integral of cosine squared of x squared times cosine x dx divided by sine squared of x, and this is equal to an integral of 1 minus sine squared of x squared times cosine x dx divided by sine squared of x. We are going to use the substitution that t is equal to sine x, and that means that the differential of t is cosine x dx. Of course, the integral then becomes 1 minus t squared the differential of t divided by t squared, which is equal to 1 minus 2t squared and plus t to the fourth power divided by t to the squared differential of t. This is an integral of 1 over t squared the differential of t minus 2 integrals of the differential of t and plus integral t squared the differential of t. This is then equal to an integral of t to the power negative 2 differential of t minus 2t and plus t cubed divided by 3 and plus c. So this is then equal to This is going to be equal to minus 1 over t. So this is negative 1 over sine x and minus 2 sine x and plus 1/3 of the sine cubed x and plus c. Problem number 98 on our list is an integral of sine 2x divided by cot to the fourth power of x differential of x. So this integral is defined only and only if cot of x is different than 0. That means that sine of x has to be different than 0, and that means that cosine of x divided by sine of x is different than 0. So x has to be different than kp, where k is an integer, and of course cosine of x has to be different from 0, which means that x has to be different than p half plus lp, where l is an integer. So the area in which this integral is defined is the set of real numbers without the dots kp, where k is an integer, union the dots p half plus lp, where l is an integer. This integral can be written as 2 integrals of sine to the fifth power of x cosine x divided by cosine to the fourth power of x dx. So this is 2 integrals sine to the fifth power of x divided by cosine cubed x dx. We can use the substitution that t is equal to cosine x, and that means that differential of t is equal to negative sine x dx. So this is going to be equal to 2 integrals of sine squared x squared divided by cosine cubed x sine x dx. So this is 2 integrals of 1 minus cosine squared x squared divided by cosine cubed x sine x dx. So this is equal to negative 2 integrals of 1 minus t squared squared divided by t cubed differential of t. So this is negative 2 integral of 1 minus 2t squared and plus t to the fourth power divided by t to the third power dt. So this is equal to negative 2 integral t to the power negative 3 differential of t and plus 4 integral 1 over t differential of t minus 2 integrals of t dt. So this is equal to negative 2 times t to the power minus 3 plus 1 divided by minus 2 and plus 4 ln of the absolute value of t minus 2t squared divided by 2 plus c. So this is equal to 1 over t squared plus ln t to the fourth power and minus t squared and plus c. So this is equal to 1 over cosine squared of x and plus ln of the cosine to the fourth power of x minus cosine squared x and plus an arbitrary constant c. Problem number 99. Integral sine 2x cot to the fourth power of x dx. So cot of x is defined as cosine x over sine of x. So the area in which this integral is defined is for sine x different than 0. That means that x has to be different than kp, where k is an integer. D is then set of real numbers without the dots kp, where k is an integer. So this is then equal to 2 integrals sine x cosine x times cosine to the fourth power x divided by sine to the fourth power x dx. This is 2 times an integral of cosine to the fifth power of x divided by sine cubed of x differential of x, which is equal to 2 times integral of cosine squared of x cubed divided by sine cubed x cosine x dx, which is equal to 2 times integral of 1 minus sine squared of x squared divided by sine cubed x differential of cosine x differential of x. So this is then equal to, using the substitution that t is equal to sine x, differential of t is cosine x dx. So this becomes 2 times integral of 1 minus t squared squared divided by t cubed, and this is differential of t. So this is 2 times an integral of 1 minus 2t squared plus t to the fourth power divided by t cubed differential of t. This is equal to 2 integrals of 1 over t cubed differential of t minus 4 times integral of 1 over t differential of t and plus 2 integrals t dt. So this is equal to 2 times t to the power minus 3 plus 1 divided by minus 3 plus 1 and minus 4 ln of the absolute value of t and plus 2 times t squared divided by 2 and plus an arbitrary constant c. So this is negative 1 over t squared minus 4 ln of the absolute value of t and plus t squared plus c. So this is equal to negative 1 over sine squared of x minus ln of the sine to the fourth power of x and plus sine squared of x and plus c. Problem 100 on our list is an integral of cosine cubed x differential of x divided by 4 sine squared of x minus 1. Area in which this integral is well defined is for 4 sine squared of x minus 1 different than 0. That means that 4 sine squared of x has to be different than 1 and sine squared of x has to be different than 1/4. That means that sine of x has to be different from 1/2 and sine of x has to be different from negative 1/2. This means that x is different from p over 6 plus 2kp and x has to be different from 5p over 6 plus 2lp, where k is an integer, where l is an integer. Of course, x has to be different from negative p6 plus 2pp, and p has to be an integer. Of course, x in this case has to be different than a negative 5p over 6 plus 2rp, where of course r is an integer. So area in which this integral is defined is set of real numbers without the dots p over 6 plus 2kp, then negative p over 6 plus 2pp, then 5p over 6 plus 2lp, and then negative 5p over 6 plus 2rp. And of course, all of these numbers k, l, p, r are integers. So the integral is then transformed into an integral of cosine squared x cosine x dx divided by 4 sine squared x minus 1, and this is equal to an integral of 1 minus sine squared x cosine x dx divided by 4 sine squared x minus 1. So we are going to use the substitution that t is equal to sine x, and then we get that differential of t is equal to cosine x dx. So this is equal to an integral of 1 minus t squared differential of t divided by 4t squared minus 1, and this is equal to an integral of differential of t divided by 4t squared minus 1 and minus an integral of t squared divided by 4t squared minus 1 differential of t. So this is equal to an integral of dt divided by 4t squared minus 1 and minus 1 quarter of the integral 4t squared divided by 4t squared minus 1 differential of t, which is equal to an integral of dt over 4t squared minus 1 minus 1 quarter of the integral 4t squared minus 1 plus 1 divided by 4t squared minus 1 differential of t. So this is equal to an integral of dt over 4t squared minus 1 minus 1 quarter of the integral dt and minus 1 quarter of the integral dt over 4t squared minus 1. So this is then equal 3 quarters of the integral dt over 4t squared minus 1 and minus 1 quarter of the integral dt over 4t squared minus 1 can be written as 1 over 2t minus 1 multiplied by 2t plus 1, and this is equal to a divided by 2t minus 1 plus b divided by 2t plus 1. This is equal to a times 2t plus 1 and plus b times 2t minus 1 divided by 2t minus 1, 2t plus 1. So t in brackets we have 2a plus 2b and then plus a minus b is equal to 1, which means that 2a plus 2b is equal to 0, a minus b is equal to 1. That means that a plus b is equal to 0, a minus b is equal to 1. 2a is equal to 1 then, and that means that a is equal to 1 half. B is equal to negative a, and that means that b is equal to negative 1 half. So the integral is then transformed into 3 quarters multiplied by 1 half integral of dt over t2 minus 1 and minus 1 half integral of the dt divided by 2t plus 1 and minus 1 quarter of the integral dt. We are going to use the substitution that u is equal to 2t minus 1 and that v is equal to 2t plus 1. That means that the differential of u is 2 differentials of t. 1 over 2 differential of u is equal to differential of t. Differential of v is 2 differentials of t, which means that 1 half differential of v is differential of t. So this is equal to 3 quarters times 1 half of the integral du, 1 quarter of the integral du over u, and minus 1 quarter of the integral dv over v, and minus 1 quarter t. So this is equal to 3 divided by 16 ln of the absolute value of u minus 3 divided by 16 ln of the absolute value of v minus 1 quarter t, which is equal plus an arbitrary constant c, which is equal to 3 over 16 ln of the absolute value u over v, which is 2t minus 1 divided by 2t plus 1, and then minus 1 quarter t and plus c. Finally, this is equal to 3 over 16 ln of the absolute value 2 sine x minus 1 divided by 2 sine x plus 1 and minus 1/4 sine x, and then plus an arbitrary constant c. So thank you for watching. If you have found this video to be somewhat useful, please like, share and subscribe to the channel. I am looking forward to reading your comments, and if you want to see my previous video where I have solved 100 integrals, you can do that on the link on the screen.